Hello, welcome back to day 16 of the 90-day data analyst little experiment that I'm doing to see if I can get hired in 90 days of work with um, let's see what we're doing here. So the first 15 days were just refreshing skills. We're going to continue kind of refreshing skills as I go along, but going to focus more on projects for the next 15 days or so. Probably the next 20 days, because I'm trying to do 4 weeks at a time here. Didn't really put in the full 20 days for for refreshing skills, but really just felt like I needed to get back into building projects and stuff. So today, our goal is just going to be to get inspired. Going to be working through a couple of books that will help me refresh skills and also to get back into the project mindset of gathering data, thinking about what can I do to this data? What can I do with, what questions can I formulate and then answer on the data? So, going to be a little slow going to get started with this week, but we have a lot to get through here. This set here, and apologies if there's going to be any background noise that's going to happen. It is President's Day, and to those who are protesting the current president, who is an unelected billionaire, going to take that stance. Elon Musk is basically pulling the strings now. So appreciate you for doing so, for protesting. I'd like to. I'm in Arizona, though. My state, I don't think there's going to be much to come of doing a protest at the capital of Arizona, the state capital. Our state attorney general is vocal about the threat to democracy happening right now. So I feel, as far as being in a state that cares about democracy, I don't know. I feel about they're doing as best they can in this state. Really wish Congress would step it up and start fighting for the people, because you can't, you have to be completely tone deaf to continue to try to fundraise while all this is going on. Like, what do you, like, come on, guys. Seriously. What the hell is going on? You can't even, you're just telling us that you can't do anything unless you have a majority. Absolutely nothing. There's nothing you can do. Absolutely nothing can be done. If you follow on me on Blue Sky, I might retweet a bunch of Brian Keegan tweets or skeets that he's been saying stuff like this. I'm getting off into a tangent here before we even get started, but I really just want to make a point of this. Let me see something. Let me bring up Brian Keegan's stuff. Here he is. So on the left side here, we've got into Boulder Progressives, but he's been. Where are the retweets? Yeah, congressional Democrats. We can't do anything. Boston University is building a database of data sets that have been scrubbed from agency sites. Find lost data. So he's a great follow. Keep track of what's going on with the data in data.gov and yeah. So I've been liking a bunch of his stuff. Yeah, I'm just keeping track of what's going on. I'm still trying to stick to my plan here and try to focus on state government jobs and nonprofits, but keep moving along with the plan, which is to the plan is to get hired here. So I'm a little distracted here, so I apologize for that, but I'm just checking my to-do list, the things I gotta do, review the calendar, eat a frog. I don't really eat a frog, but it's okay. We're gonna get inspired today. And there we go. And we had that from yesterday. So I'm gonna hide that, and actually I usually bring that up over here. Yeah. Okay. That's weird. Just open it up right here. There we go. We have our job search dashboard. That's good to keep an eye on. That was the monthly note. I think I can get rid of that. I can hide that and close that. The plan. I want to have the plan up on here. Right. Q1 plan. Just revisit my plan here. SQL, Python. I think we're going to get into some SQL. Documenting the process clearly. I haven't been doing a great job of that. I've been documenting with the videos here, right? But as far as clearly, I think I could do better with doing some clear communication. I'd like to get a blog set up and consolidate a lot of the things that have come up in this journey, and right on some of the technical aspects that encountered, and then also on just general vibes of doing a job search in this time, and just trying to keep engaged with this. Okay, so we're in the phase where preparing for interviews should come. So applying for jobs and then preparing for interviews coming next month. Gonna start that, I think, on the 17th of March. So it's about a month. Yeah, it's right, because 28 days in February is exactly 4 weeks. So 17th of February starts my month of building projects, and then the month of applying to jobs, preparing for interviews is going to be in March. And I will try to. I'm going to focus on doing some stuff. So I do have a calendar. I wonder if do I feel good, comfortable sharing this? Let me see. Let me see if I got my 4 weeks there. Yeah, I feel good sharing this. Let me full screen this, actually. So this is my calendar that I made. Planned this out last week on Friday, and or over the weekend, I think it was actually Saturday. So we're gonna first week we're gonna focus on the data and sampling distributions from the Practical Statistics for Data Scientists book as our kind of like just general practice of refreshing skills and doing just a little bit less of that. Then focusing on building the project. So I'm going to be reading David Asboth's, is it Asboth or Ashboth? His book, The Well-Grounded Data Analyst, and going to dive into chapter 1 and chapter 2 today. And that's going to be bridging the gap between data science training and the real world, and then encoding geographies is the first project in chapter 2. And so, yeah, it's President's Day. So I just have my thing like general, going to work on projects. So let me, instead of going into that fine grained detail, let's take a big picture thing and just look at week over week. So week over week, we're just going through the book for the Well-Grounded Data Analyst, doing that 3 days a week. 3 days a week we will be focused on that book and working through the projects in there. And that's going to continue into the next month. That's going to continue into March. Because there are just a few other things. Iterating on someone else's work. Oh wait, no, we're gonna aim to complete that this month. Yeah, in the coming four weeks here. Then we're gonna also focus on and then the learn part. We're gonna go through the Practical Statistics for Data Scientists, chapter 1 and 2, I think, or chapter 3, and then chapter 4. Yeah, I think this is chapter 3 and 4. I think these have to be kind of broken up though. I have to break those up. So I didn't realize that I had to do that. But the general structure is going to be 3 days of project work, except for this first week. I'm going to try to get some gears churning for project ideas. So week 2, 3, and 4, I'm going to do Tuesday, Thursday, and Friday doing the David Asboth book. That's the Well-Grounded Data Analyst. And then on Monday, I'm going to focus on applying and networking. So starting next Monday, we're going to start doing that every Monday. So I figure like Monday's usually the time where I am the most the best rested, the most well rested, the most rested. I'm well rested generally on Monday, and that generally makes my mood a lot better for trying to do things I don't want to do, which is networking and applying to jobs. So we'll focus on that on Mondays, except for today because we got to get the gears churning here. Then on Wednesday, I'm going to have a learn day, kind of like a learn something new. Try to do something like that. So for this coming Wednesday, I have linear regression in Python. This is more of a refreshing of skills because I've done this before with scikit-learn. I do need a refresher on that, but it's also going to be, I think, something that I'm going to learn a little bit deeper on with this article from Real Python. So that all these streams for the week are scheduled. You can see them on my YouTube page, and you can get notified if you click on the why don't we go through that? Why don't I just go into that right now? Let's go to So it is like you can access my site with Kevin.weatherwalks, or you can access it as KevDubData. That's kind of the moniker that I'm trying to take on here for this focus of this channel. I'm probably going to branch out into some other channels. So I have my other channel, this Data Cross Puzzles. I'm also going to look into doing a more personal channel for just my Kevin Weatherwalks channel, and that's kind of that would be more generic stuff outside of the focus of data analysis, data science. Okay, so let me show you here. So you can get notified on upcoming streams. If you go into the page here, you'll see if I'm live now. I don't know, like that just pops up anyway. Yeah, I don't know if I need to put that live now there then. So you'll have upcoming streams, so you can go and get notified that that I'm going to be starting there. These times are tentative. I do have something to do tomorrow in the middle of the day, so I'm going to try to get early. Might even be earlier than 9 a.m. So, but by the time 9 a.m. kicks around, it will probably be into the meat of the stream, of the workday, I should say. And then yeah, so linear regression in Python on it's gonna be Wednesday. Tomorrow we're gonna do data modeling project. We're gonna do a metrics project on Thursday, and then an unusual data sources project on Friday. And so we've got a lot to do. I think what I'm going to do is get started here. And what I need to do is to get a couple things started. Need to get my code editor here. Oh, I don't know why that flashed on the screen. That's kind of odd. Let me get my code editor. So I'll get my code editor up and we'll see into projects. I don't remember what I was doing for this, honestly. It was professional, right? And then it was practical statistics for data scientists. Yeah, where was I? Where did I put that? Huh. I'm very confused because I don't remember where I put my my project for that. Oh, right. It was in data analysis projects. Okay, so that's what I was doing. Right, and we already have a virtual environment for that. So let me get that opened and going. Okay, so so we'll get that going. Okay. Okay. And I'm not sure where I really want to have my code editor. I was putting it off to the side. I did make some edits to the general format that I'm going with here. Let's see. And please let me know if that is a little annoying with the VS Code thing popping up. I just thought it might be a little easier to see like what I'm working on. By having a little zoomed in view. But if it's gonna be not good, then let me know. Okay. So we left off with Data and sampling distributions. Do I want to continue with the R Markdown? I feel like I don't want to. I feel like at this point, it's just gonna kind of hold me back, and I'd rather just like focus on one. So I think I'm gonna scrap doing any of the R language stuff, especially since I don't think VS Code is good for R for R Markdown at this time, unless I find something like that, a workflow that is a little better. I just don't like having to open up a browser and refresh the browser and do all that stuff every time that I knit the document. With I remember with RStudio, you can like knit the document, and then a little like inside of the RStudio they have a web viewer, and then you can see it there. You're sending heartbeat. Interesting. What do we use code? Okay, that's weird. Okay, so I'm gonna add a stream marker there. Okay, it was added. It said that it wasn't. Okay. So we are up to long-tailed distributions. So just review what we've done so far. And we got the data set, curled that in, import pandas, matplotlib, and then seaborn, right? Our sample data for sample data frame and sample means, and yeah, right. And we're just investigating some of the with the central limit theorem, right? With the more samples you take of the mean, the closer it gets to a normal distribution, right? Yeah, okay. We saw that. So when you just take the original data, you have it kind of looks a little bit left skewed. But when you kind of looks a little left skewed, but then take repeated samples of the mean of 5, right? 1,000 times. So 1,000 samples of 5, sampling 5 elements of the data, taking the mean, and then doing that 1,000 times, basically. And yeah, so if you have a smaller sample size, it still kind of looks a little bit. It still looks a little bit left skewed, honestly. But the higher the sample size, to increase the sample size, gets closer to the mean. It's much closer to yeah. And I imagine if you take yeah, I would imagine if you bootstrap it. Well, that one, I don't know. I don't know if bootstrapping would help there. Not sure. Right? We did do bootstrap using resample from sklearn utils, investigate confidence intervals, and let's see. Yeah, we created sample 20, the resampling, and samples of 20. So that's just sampling with replacement. It's like resample. I don't know. It just doesn't seem like the right term for me. Just sampling with the replacement. constructing confidence intervals and you're taking the quantile from 0.05 and 0.95. Interesting. Right, okay. And plotting. I don't know why I didn't like really notice it. Dive in deep into it. I did this. 90% interval, that probably should just be a backspace. So see that, but I don't know. It's good. All right, so then we generated a 90% confidence interval. So we figured out the quantiles for 0.05. That's going to be at 43212, 43,212. 70,233 is where the 95. So you can say 5% of the data lays below 43,212. And then 95% of the data lies below 70,233. The mean, so, is 55,806. Mean and not the median, but it does look like it's pretty, well, it does look a little left skewed, doesn't it? If I'm just measuring here and then measuring there, it does look a little bit left skewed. Yeah, and then that's a 90% interval, which is interesting because I always thought that it was like the same distance between. Yeah, isn't it? Because I thought you usually did the inner quartile range for the calculation of the interval. Where you take the mean and then plus or minus like 1.5 times the inner quartile range. I thought that was the standard way of doing that. What notes do I have on that? Bootstrap confidence interval. Huh. Is that the same distance? Let me just check something here. 43. It's false, but like in what way? In what way is it false? Yeah. Yeah. There's only 12,000 and then there's 14,000. Do I not like, what was the, oh, that was margin of error, right? Margin of error is 1.5 times the comp, okay. Wait a minute. Maybe I have to like search through the entire thing. It'll take a while. Should install OmniSearch. Yeah, this is weird. Right, so that's the confidence interval. I just thought it was this margin of error. Margin of error is 1.5. Yeah, I don't know why I'm having a hard time with this. Right? What was confidence interval here? Look this up. Oh wait, maybe what I did was just approximations. S is, what is S? Standard deviation, right? And then C is the confidence. I'm just like a little lost on this here. This band, yeah. Right. But the margin of error is the half width, but I thought it was centered around the mean. Don't you take the mean and then plus or minus? This margin of error thing, right? What am I thinking of with the 1.5 times the IQR? Oh, I think that was with calculating box plots, actually. Like standard for outliers, right? Man, my brain just like loses all this information after 2 weeks of not doing anything with it. Yeah. Okay, so it's with the margin of error, but I thought that it was margin of error was like the true mean. That's what I'm confused about. Is like the mean is, it's clearly like left shifted. This one. I'm just very confused, right? Like, look at it. Like, it's definitely left shifted. Can I zoom in? Can I zoom again? Was it this one? I don't know why my my hotkeys aren't working. That's so weird. I thought, wait a minute, something's not right here. Disable hotkeys when window is in focus? This is so weird. Never disable hotkeys. Something's weird with this. Now, like, it works when I go over to there. So odd. I don't get it, man. Something's weird. Something is weird here. Okay. All right, so we got up to, okay, so we did normal distribution, calculating some of those, and then a Q-plot, right? Prob plot. They call it a probability plot, but I think that's a Q-plot. Theoretical quantiles in the ordered values, and you want that to be, if it's normal, then that'll be on the 45. All the points will probably, lie along that line. But yeah, if they're not, then it's not normal, right? It's a test for normality. Yeah, so this is very odd, honestly. I don't know what's happening with it. Really bizarre. Just truly bizarre. I might have to take a break here and try to figure that out. See something. Hotkeys aren't working. No, it's not Obsidian. What am I talking about? Restart OBS? No, that can't be the problem. This is a terrible. What? This isn't what I'm searching for. Bit rate would drop. Yeah, that's not what I'm asking, dude. Bear with me for a moment, folks. Zoom is not working. It is that one. Toggle zoom to mouse. Toggle that one. Yeah, it's not an issue with... Not an issue with anything else other than that. So weird. Huh. I'm really confused. I don't think it's with Zoom. Zooming. Zoom diffuse code. No, it's not that one. No, it's a different one. I don't understand. I do not understand, man. It's very strange. It's not working. It isn't working.
OBS Studio Hook is disabled.
Yeah, what is going on? I am confused. I don't know what is not working. We've got the right scenes, the right profile. It shouldn't be an issue. Yeah, I'm just really confused here. Hotkeys are not working. Disable when they're in focus. So it doesn't work when main window's not. Yeah, it doesn't work. Does not work. That's so bizarre. I wonder if... I mean, it's clearly like the... Try to troubleshoot this. The keyboard's working. The keyboard itself is working. Okay. Right, because if I do Control-Alt-Shift... Yeah, that doesn't work. Okay. Disable when not in focus. It's so weird. That is the behavior. It's disabling when not in focus, but it doesn't work. It doesn't work the other way. So they're disabled when not in focus. Yeah. Disabled when not in focus. Oh my gosh. Okay. Wow. I just don't know. Bear with me, folks. It's gonna take a while to get this stuff sorted here, I think. So, it's not working. So, sucks. Can I use the browser? There might be something. Windows 10. This has to be old though. Yeah, it was 5 years ago. Let's try to find one that's within the past year or so. Hotkeys are not working if OBS is not the current window. That's my issue. What? That's not the problem. Yeah, this isn't the problem though. Oh my gosh. Oh, wait a minute. Maybe it's just not running as administrator? Is that what happened? Shoot. Maybe that was the problem. Nope. Okay. Alright, so I might have to suffer through that for the rest of the day. Just manually switch back and forth. Oh, no, it's not working at all. Oh, it's so weird. That's so weird. Unless I'm on sources, unless I'm on active, unless I'm... If I'm in any... If I'm in the live control panel, it's not there. What if I... Hang on a second. What if I do that? Nope. It's not conflict with advanced scene switcher. The only thing I did was install DroidCam, and I don't know if that is something that's blocking it or something. Okay, I guess I'm gonna suffer through it and just try again tomorrow. See if it still has a problem. So I don't want to risk ending the stream and then starting up the stream again. I don't like doing that. Okay. So notes, resources. It's been a while since I've done this, so it's gonna be a minute to get this situated. So I know we have the practical stats, right? Practical stats. Let's open that up there. Ooh. And okay, then I think what I want to do is pop this out. I'm going to put this over on the side, and then I'm going to pop this out and put this over here. And I might have to reload it. Smart cat. She hotkey that. Okay. Okay, I'm going to skip the whatchamacallit. So I think okay, so student seat distribution, it's pretty small, pretty short here. We can just get back into this by doing some quick stuff here. Most data is not normally distributed. Assuming a normal distribution can lead to underestimation of black swans there. So I think what I want to do though is I do want to open this back up over here. Should set a hotkey for that. Right, so we didn't save the key ideas here. Oh, because we haven't even started it. Okay. Convert to z-scores. We did that. Okay, so gotta remember my note-taking strategy. Whew. Did I save something on normal distribution? I did. Okay, so what I'm going to do, I'm just going to duplicate this. Make a copy of that file, and then we're just going to call this long-tailed. And get rid of this stuff here. Oh, QQ plot was what that was. Quantile, quantile. Yeah. Okay. Long-tail distribution. So we're gonna define a tail, and this is the long. Let me mindfully go through this because it's gonna take a minute to warm back up again. Despite the importance of the normal distribution historically in statistics and in contrast to what the name would suggest, data is generally not normally distributed. You'll see that a lot. Right? So the long, narrow portion of a frequency distribution where relatively extreme values occur at low frequency. The tail, long, narrow portion of a frequency distribution where relatively extreme values occur at low frequency. Yeah, if we go back to our data here, you can see that we have a bit of a long tail distribution here, right? To the right of the bulk of the data, there's just, a few values that just go to the extremes, right? To the extreme rights here. And it's a long tail. That would be long right tail, right? And then the skew is where one tail of the distribution is longer than the other. So narrow portion, frequency, relatively extreme values occur at low frequency. Definition for skew. And did we have a note for frequency distribution from maybe in data distribution? Maybe it was frequency. I don't remember. I want to use those links again. Extreme values or low frequency. It's not really necessary for this one. One tail of a distribution is longer. What we'll do is I think what we'll just do is, tail. Yeah. Yeah. There we go. Oh boy, okay. Let's get going. While the normal distribution is often often appropriate and useful with respect to the distribution of errors in sample statistics. It typically does not characterize the distribution of raw data. Sometimes the distribution is highly skewed, such as symmetric and asymmetric distributions may have long tails, right? The tails of a distribution correspond to the extreme values, right? Long tails and guarding against them are widely recognized in practical work, and Nassim Taleb has proposed the black swan theory, which predicts that anomalous events such as a stock market crash are much more likely to occur than would be predicted by the normal distribution. He says that there's fat tails that that we would predict there to be a smaller, a thinner tail here by the normal distribution. If you look by doing these things here. This isn't true. That that tails can be fatter. That more events can occur in those regions, so that the probability is estimated of those things occurring. Good example to illustrate the long-tailed nature of data is stock returns. So go QQ plot for the daily stock returns for Netflix. And yeah, you see that there's higher side. So let's go here. Okay, so we're not going to do anything with R for the remainder of this. That was good for when I was doing what do you call it? Refresh skills, but I want to focus on doing more projects, so I'm not gonna spend as much time going into this book with the R code. Just gonna scrap that. Just free up some time for doing more project work. Okay, so we want to run all of these, right? So above, right? Execute the above cells. It's gonna take a moment. I don't think that I have the SP500 data set in here. I'm gonna actually search for this. Huh. Only in that spot? Really? Oh wow, why is it taking so long to load that data, the loans income? It's really slow. Should switch to UV. I think that could be an issue with the VEMV. Commented those out. So I guess I wanted to see the object. I don't know. So 95% confidence interval. Right, we have 90 and 95%. Now, yeah, it's clearly that there's more to collect this side. I'm just confused. Huh. So I'm thinking that like my understanding of confidence intervals is a little simplistic. In that I think what I'm remembering as it being like equally distant from the lower end of the interval, and so the distance from the mean to the lower end of the interval is the same as the distance from the mean to the higher end of the interval if we're using the normal distribution to estimate this. But if you're doing the actual confidence interval on the actual data, that's where we have this, right? That's where we do this. So I need to import the data, and I need to get that data. So I need to find out where that was, right? I do not have a browser up, so let me get one. Here. Good thing I saved this. Yeah, I could just look at the notebooks here. So it was in this one, data there. And he's going to load in the SB500 data from there. And I think what I'm going to do is curl in that one from here. And let's do a separate one here. So what we need, data, loans, income, we're going to call that SP 500 data. Do I have it? I think I might. I think I might have it. Maybe I just didn't load it in. Oh, we do have it. We don't need to curl it. Okay. We just need to load it. Right. So we're just going to load a data set. So how long has it been? If I can't do this by memory, right? So I take it from the oopsie doopsie data and SB 500 data. Right. Okay. You can take that in as the zip file. That's so fascinating to me. Path. Resolve the path. Data. Well, maybe that was my problem. Can we do that random seed stuff? Oh. That's weird. I guess I didn't code that. You just had images of it. Okay, so okay. The bootstrap and sampling distribution. Right. So this is just the code for figure 2.1, right? Right. Okay. Right. Okay, so he is just reading that straight in. There's nothing special about that. NFLX there. Let's hide that now. NFLX is gonna be that there. Let's go ahead and do this. It's so slow. Unnamed index. All right, so we have some stock symbols in this wide format here. If we wanted to make this in long format, then we would have stock type or stock ticker name, and then, yeah. Right, multiple days. Okay. So, and we're just going to be looking at one specific stock, and that's NFL X. I don't know what that is. Is that just the NFL? And we're going to take the difference. What does this do? Oops, sorry. Calculates the nth discrete difference along the given axis. I feel like I looked at this before, once before. I just forgot what the heck it is. Nth discrete difference along the given axis. Okay. Okay, so we're looking at differences between the next value and the previous. Okay, I think that's what we're doing, right? And the axis being probably going to go along the columns. I'd imagine that the default is column, right? Int is optional. Default is the last axis. What is the last axis? What does that mean? Because it goes row column, and so the last one would be the column. Let's see if we have the axis equals 0 and p difference of this array. So we're looking at, oh, that's weird. -1. So 2 to 3 is -1, and then to 2. Oh, and then it calculates the next row. Oh, okay. So it's going to go through every single row. Or every single column, I think. And since we're taking a series, it's going to go through every single one. But we're doing a log transform first. Which one is it? Shift space? Weird. There's no... Yeah. Can I get format hints? Control Shift space. There we go. Don't even remember my own hotkeys for these things. Okay, so... But it's not coming up correctly. Let's see. Yeah. I don't... ND array. Oh, these are just parameter hints. Yeah, okay. But then... the difference right there. Oh, because that's in... yeah. There's no real hints for the log. I don't understand why. They're just lacking on the documentation here. Pretty sure we're just doing a log transform here. These have to be differences, though, right? From the day before. So we're taking the difference of the differences. Which would be like the acceleration of the stock market. I guess that could like give you a sense of like what the force is, what the general trend, what's happening there. Unless I'm mistaking something, I don't understand this. NFL. Oh, I think this is actually Netflix. It's not NFL. Okay, so it is Netflix. I didn't even read. I don't read. Oh gosh. Okay. Why am I in a caps lock? So we want it where it's positive. The difference is where they're positive. I'm just very confused by this because why? What are we doing here? You're just ignoring the negatives? Ignoring the dips and only the positives? I don't understand why. Why would you do that? Let's get a figure, an axis handle, and do some subplots. Let's get this up over there. Stats. Okay, so we're gonna do a this is very laggy for some reason here. We have our stats model. Yeah, so looks like there are some extreme values, right? In the lower and the upper ends. Once we take the log transform of that. If we didn't do the log transform, would it be about the same? Would it be like even wonkier? That's what I want to know. Let's do the same thing. Oh, wait a minute. Yeah, let's do the same thing. But without the log transform? Yeah, it's so goofy looking, isn't it? Huh. And then why do we not use the negatives? All right, well that's goofy as shit, right? So we cannot do that one. Okay, there's like some extreme values up there. Maybe there's just probably, well, I don't know. Probably not few negative ones. So what is this data anyway? Daily stock returns. Stock returns. What is a stock return though? We're already getting into finance and I don't want to deal with it. Give a shit. I'll happily be ignorant of that. The points are far below the line for low values and far above the line for high values, indicating the data are not normally distributed. Right, yep, so we got some of those ones. This means that we are much more likely to observe extreme values than would be expected if the data had a normal distribution. Okay, so I'm going to highlight this because I think that's important to understand. If it had a normal distribution, we'd expect everything to fall along those, like that there would be very few extreme values, right? But this shows that maybe there's more things going on. There are more values in the higher end, and there's actually fewer values in the lower end, so it's kind of skewed, right? The points are close to the line for the data within one standard deviation of the mean, and Tukey refers to this phenomenon as data being normal in the middle, but having much longer tails. And there is much statistical literature about the task of fitting statistical distributions to observe data. Beware an excessively data-centric approach to this job, which is as much art as science. Data is variable, often consistent, and on its face with more than one shape and type of distribution. It is typically the case that domain and statistical knowledge must be brought to bear to determine what type of distribution is appropriate to model a given situation. For example, we may have data on the level of internet traffic on a server over many consecutive 5-second periods. It is useful to know that the best distribution to model events per time period is the Poisson. Yep, events per time period. It's how you can model how many goals might be scored in the course of a 60-minute hockey game. You can model that with Poisson. Most data is not normally distributed. Let's go ahead and get over here and get over here. Over here, over here, over here, over here. Yeah, I don't know why I have this on. Back out of studio mode. There we go. That's better. Okay, most data are not. Distributed. Everything's so kind of sluggish here on my computer. Underestimation of extreme events. Boo. Yep. Black Swan. I read that a while ago. Before I really had a good idea about statistics and stuff, so I'm probably didn't understand it as well. And took some of the wrong messages and stuff. But I think I understand it a little better now. In retrospect. All right, so I'm going to do the students' t-distribution after I take a quick little break. I just got to clear the head a little bit here. Yeah. Up there, going to there. Yeah, there we go. Okay. Yeah. Just need to take a quick little break after here. And actually, what I'll do is I'll just set this up before I go, because it's just, Students' t-distribution from the guy named Student. I don't think that's true. All right. We'll come back and do that. But yeah, I think I want to just try to get this automation set up. When I collect the be right back scene, how do I set text be right back and then give stream from stream? Yeah, we're gonna shove that back on there. That's okay. Yeah. Okay. Actually, I think all I'll actually do is just to change the source. Oh, you know what? Yeah. Scene item visibility. Okay. What else do I want to have happen here? Yeah, so I only want this to really trigger once, right? Yeah. 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 Trigger that once. It's running for, let's say, for 20 minutes. Actually, you know what? Yeah, 20 minutes sounds good. Yeah. That gives me enough time to set everything up. Right, but then when we switch and change, be right back. If fails, yeah, I want to set the set that. Under. I think maybe it's hockey. That's not it. Okay. Oh. Right. Okay. That's where it is. Front end. Okay. Break timer, right? Set countdown. start. Okay. And think condition change. Only on condition change. Okay. All right, we'll be back in a little bit here. Okay. Looks like we got a couple views here. That's pretty good. Gonna get started on the student's t distribution and finish up this finish up this section of practical statistics for data scientists. Okay, so we got definition here, t distribution. Let's take that as our definition here. T distribution. So it's a normally shaped distribution, except that it is a bit thicker and longer on the tails. Okay. It's not really a definition of it. It's used extensively in depicting distributions of sample statistics. Distributions of sample means are typically shaped like a t-distribution, and there is a family of t-distributions that differ depending on how large the sample is. The larger the sample, the more normally shaped the t-distribution becomes. Okay. So in the sample size, and then, key terms here. I'm going to keep an eye out for a clearer definition of what the t-distribution is. Definition. There we go. Degrees of freedom. So, okay, yes. Let's say the parameter that allows the t distribution to adjust different sample sizes, statistics, and numbers of groups is known as the degrees of freedom. And we will the key distribution here. Key distribution. Does that work? No, it doesn't. Weird. Just do it as that then. Okay. That's so weird. The T looks like it's capitalized. Yeah, could be. Okay. Well, whatever. So the T distribution is often called student's T because it was published in 1908 in Biometrica by W.S. Gossett under the name student. Right? Gossett's employer was the Guinness Brewery, and they did not want competitors to know that it was using statistical methods, so it insisted that Gossett not use his name on the article. I don't know if they wanted them to know. Didn't want people to know their statistical methods, but they probably didn't want to know that specifically they were innovating these things and applying it to there. Well, actually, yeah, I guess you would want to just hide it in general that you're using statistical methods. I don't know. All right, so Gossett wanted to answer the question, what is the sampling distribution of the mean of a sample drawn from a larger population? Right. That's what we've been looking at from doing these samples, right? Yeah, building up from there. Okay, so you started out with a resampling experiment drawing random samples of where am I? 3,000 measurements, criminals' heights, and left middle finger length. This being the era of eugenics, there was much interest in data on criminals and in discovering correlations between criminal tendencies and physical or psychological attributes. It's, yeah. Sadly, there's a lot of interest in this again from people in power, and especially our tech billionaires. Gossett plotted the standardized results, the z-scores, on the x-axis and the frequency on the y-axis. So he had separately derived a function now known as student's t, and he fit this function over the sample results, plotting the comparison. Okay, so Gossett's resampling experiment results and fitted t-curve from his 1908 Biometrica paper. Looks like it's like hand-drawn. Just like a ruler and, yeah. Data points there, interesting. Right, so a number of different statistics can be compared after standardization to the t-distribution to estimate confidence intervals. That's what I'm getting at. That's what I was thinking of. Estimation of confidence intervals in light of sampling variation. Consider a sample of size n for which the sample mean x bar has been calculated. If s is the sample deviation, a 90% confidence interval around the sample mean is given by, right, plus or minus this tn minus 1. That's a value of the t statistic. And you multiply it by the... Oh, okay, wait a minute. This is a function, right? T of 0.05. Multiplied by that. So I want to take that, and we're probably going to want to know what the t statistic is. I don't know why that's not really why that's not really on there. But let's get a Rx TM, I think, is the one there for plus minus. And then we want to do T sub n minus 1 as a function of 5. And then we want to center dots and do a nice fraction here. Let's go display frac, even though we know that we're not going to really use that anyway. So we'll do square root of n. And I think that'll work. And, yep. Yeah, that works. Okay. So let's say let's just say 90% CI. Estimation. Yeah. Yeah. There we go. Okay, so value of the t statistic with n minus 1 degrees of freedom, and that chops off 5% of the t-distribution at either end, so the top and the bottom, right? So the t-distribution has been used as a reference for the distribution of a sample mean, the difference between two sample means, regression parameters, and other statistics. So had computing power been widely available in 1908, statistics would no doubt have relied much more heavily on computationally intensive resampling methods from the start. Okay. Lacking computer statisticians turned to mathematics and functions, such as the t-distribution, to approximate sampling distributions. Computer power enabled practical resampling experiments in the 1980s, but by then, use of the t-distribution and similar distributions had become deeply embedded in textbooks and software. So the t-distribution's accuracy in depicting the behavior of a sample statistic requires that the distribution of that statistic for that sample be shaped like a normal distribution. And so, like, I kind of want to come back to this point in this because we see, like, we calculated exactly the exact confidence interval here, right? Exactly. We calculated it exactly from the quantiles, right? And that could be a pretty expensive thing, right? To calculate. And right. Right, because you have to sort all of the values, right? And that if you're doing that by hand and you don't have computation at your fingertips here, that would take a long time for any meaningful size of a data set. And so it relied more on estimations from mathematics. Okay. All right. So the t-distribution's accuracy in depicting the behavior of a sample statistic requires that the distribution of that statistic for that sample be shaped like a normal distribution. Seems right. It turns out that the sample statistics are often normally distributed, even when the underlying population data is not, right? And this comes back to the central limit theorem. This brings us back to the phenomenon known as, yeah, there we go. What do data scientists need to know about the t-distribution and the central limit theorem? Not a whole lot, but the t-distribution is used in classical statistical inference, but it's not as central to the purposes of data science. Understanding and quantifying uncertainty and variation are important to data scientists. But empirical bootstrap sampling can answer most questions about sampling error. However, data scientists will routinely encounter t-statistics in output from statistical software and statistical procedures in R, for example, in A/B tests and regressions. So familiarity with its purpose is helpful. Okay. All right. So that was a short but definitely important little section here. So the t-distribution is actually a family of distributions. I'm surprising we didn't do any kind of graphing of that normal distribution, but with thicker tails. Right? Might be used as a reference basis for the distribution sample means. Differences between two sample means. Regression parameters. Okay. Further reading is available as a PDF. Go here. Yeah. Let's see. Mean. So I guess I'll just Yeah, I guess I'll download that too. I don't know where I was putting it. uh, yeah. Okay, I don't know where I was putting it though. Guess in inbox? Did I put it in inbox? Hmm. I think that's kind of where I want to put it. I don't know why I was like doing that in other notes or something. Okay, so we can link to that here. Student's original paper. Standard treatment can be fine, but David Lane. David Lane sounds familiar. Oh, I think it was David Lay who did this. Linear algebra books. Let's see here. Objectives here. Okay. Oh. Online stat book. Yeah. All right. Well, we'll just take the link for that then. That. Okay. And then what practical statistics did we do today? We did normal distribution and long-tailed. Do I want to put it under notes? I don't remember what I was putting it under. Still didn't get a definition for that, but I kind of just want to move along. Okay. Let's see here. Okay, I'm gonna shift focus on over to Well-Grounded Data Analyst, and I'm going to read from the start, and then what I want to do. There we go. Okay. All right, so we have our chapters, we have excerpts and quotes, and we have my notes, and then what was I doing for that other one? So I'll do that. Download. Yeah. Okay, chapters there. Key ideas is what I want to add, I think. Related notes under repetitions. Interesting. Okay. Well, okay. citing this book, I want to have citing this book on there as well, right? That was underneath my notes. Let's get the same format here. What we're going to do is go back up to here, chapters, and then okay. I'm gonna do some gonna take some time to re up this thing. Page width. So this is the book. You can check the description for a link to the book from Manning Press or Manning Publications. You can get the ebook itself, or you can get the ebook and the print one. And the print is like, if you do them both, there's like a little bit more. It's like I think like a $15 more charge or something along those lines. It's not much, honestly. It's really just for mainly just for the I think the printing and the shipping. So it's very reasonable for getting the print copy, and the main bulk of it comes from the price comes from main bulk of the price comes from the ebook. It's the content that matters, right? And so I love Manning as a publisher. They're I have several books of theirs that I have not started on. I also have the Well-Grounded Python developer, something like that. Yeah. I want to do that one as well. But I'm focusing on the data stuff right now. Sarah. Gonna have to do some setup here. Real Python, that practical stats for data analysis. And so what I'm gonna do to create a new okay, so let's exit out of these R terminals and the other one. So I don't know why they were so weird. Okay. So we want not touch. We want to make a directory called Well-Grounded Data Analyst. Yep, right here. And we have those. What is my README for? Collection of projects and tutorials worked on. Where my job search of 2022. Yes, okay. Requirements, I did do something on the Lincoln Riley thing. I should put that into another folder, but I'm not going to worry about that right now. So we got that directory set up. We have our Venn already set up. Might need to do some other stuff. So we have a results-driven process to apply to any data analysis problem. I think this is probably a image that we're going to come back to again and again. So I think what I want to do is to print out a page of this. No, I don't know. Presentation mode. Current view, copy, or open in new. folder. I don't know what any of this stuff does. The last page, odd spreads, even spreads. And tool vertical scrolling. Oh, what's rapid scrolling? Curious what that is. That would be fun. I think it would be like the next one. Yeah, I don't know. So I kind of want this image to come back to this again and again. This seems like an important thing. So I think what I want to do is to take from the excerpts and quotes. I think what I want to do is to go actual size. No, that's not it. Page fit? Page width. I don't know. We can zoom in. Not 220. Let's try 150. I just want to get a full picture of this in the best fidelity possible. So I'm going to copy this. And I'm going to paste it into here. And then the pasted image is going to be renamed. Yeah, there we go. Open pasted image, PNG. What I want to call this is the assets from there. We'll just, yeah, I think we have to rename it, right? Rename. Right. So I will rename this as the results-driven process. To analysis. Or I'll say 2D analysis. And from there, I'll just link that to what we have there. And actually, well, I guess we need to limit the size of it. No, it's not that. Height. 200. Or 150, I think. There we go. That looks okay. Actually, yeah, I think that's fine. So we're going to copy that, and I'm just going to go back over to, let me see this one goes. Okay. Copy that, go back over here. We have our notes and our resources for today. Our notes are going to be here as well. Yeah. So you need to understand the problem. You need to start at the end, you know, what you want to accomplish. You want to identify additional resources, obtain the data, do the work, present the minimal viable answer, and then iterate if necessary. So this is going to be a process that I guess we're going to come back to time and time again throughout this book. And so I think what we'll do is let's go back to page width. Actually, yeah, I think this is fine. The well-grounded data analyst. Solve messy data problems like a pro. Yeah, that looks good. No part of this publication may be reproduced, stored in a retrieval system. Oops. I mean, I'm going to try to add as much commentary as possible for this to qualify for fair use. So if there's a problem with this, just reach out to me and let me know. But I'm going to assume that what I'm going to do is falls under fair use because of the learning aspect of this and also the commentary that I'm going to add to my wife, Barbara, who has always believed in me. Nice. Okay. Brief contents. We have bridging the gap between data science training and the real world. That's what we're going to tackle today. We're going to also tackle encoding geographies. And then tomorrow we're going to do data modeling. Looking forward to that data modeling stuff. It's always a topic that I kind of like digging deep into. So we'll look at the data analyst toolkit, a results-driven approach, and a project structure, and then dive into a project identifying customer geographies and using a data dictionary. Probably creating one too. And we have a foreword. I think this is by Reuven Lerner. So in the modern world, data is everywhere. Applications run by governments and companies collect data about the world and about our actions. We walk around with smartphones, which constantly collect data about our movements, purchases, and preferences, and then share that information with a wide variety of companies. The good news is that this data makes it easier than ever to ask interesting questions about this world, ourselves and our customers, and get coherent answers. Bad news is that you need to find the data that will allow you to solve the problem, which isn't trivial. You then need to clean that data and modify it to suit your purposes. Only when you have wrestled the data into submission can you finally start to perform analysis, and then when you finally have answered your questions, you have to decide how to present your analysis to others. That's what I kind of find like interesting about statistics and data science in general, is that like you don't need to be exact like with the mathematics and stuff. Like you don't need to have a rigorous proof-based approach to getting actionable results. You can use estimation. It's really just like estimating whether, taking estimates and acting as if they're true, right? Like, because if it, it's just the best evidence that you have to act on. So let's see. Each of these steps in itself can be quite frustrating, and they require practice and understanding. For beginners, worse than that, because it's not clear where to start. Even if you have lots of experience with Python and Pandas, that doesn't mean you know how to solve problems, much as knowing how to use a hammer and screwdriver doesn't necessarily make you qualified to take on a carpentry project. That's where this book comes in. David Asboth gives you a clear set of steps to follow when you want to solve a problem. Follow these steps and you'll know what questions to ask at each stage of a project, what inputs you'll need, and what outputs you'll be creating. Sounds good. For example, David tells you to start a project by understanding it, and then by starting from the end, that is thinking about what answers you're trying to find and who those answers are meant for. That's generally the process that I've been accustomed to. Even though like I kind of like lost sight of that, like it's kind of like you usually start with a question and then you gather the data and like, so, well, what data do I need to answer this question? What would an answer look like? How do we know when we've answered the question? Basically, right? Right, and these might seem obvious to someone who experienced the data analysis problems, but as I've repeatedly seen in Pandas courses, it's all too easy to forget or ignore them, right? Sometimes you can just like dive into a data set and then get inspiration from there. Just kind of like questions might pop up when you look at a data set, and then like, yeah, that's one way to go. But the general, the results driven approach is to think of, well, we have this problem we want to solve. let's put that into a data analysis question and figure out what we need to answer that question. And then go through the steps, right? So kind of similar to what I'm doing here is like try to figure out like what do I need to become a data analyst and to get hired as a data analyst. So we figured out like some steps and then we're executing that plan, right? So David guides you through solutions, not only explain how to solve them, but what pitfalls you might encounter, what trade-offs. Every project in the book uses real-world data, which is always problematic and dirty. As you work through the examples, you'll learn how to handle such problems, including how to decide what's worth keeping as opposed to throwing away. Well, of course, what would it be opposed to? No analysis project ever truly ends, right? It's thus appropriate to find the final step of David's strategy is iterate, right? Because like generally, like you can get some good estimates, like you can get crude estimates and then you can refine them to be more accurate, right? To be more precise, right? More accurate and more precise probably is what you're aiming for. Once you've gotten an answer to your question, don't spend too much time congratulating yourself. Although I'm thinking like if you're going to get crude estimates, you probably are putting pretty wide bounds on your estimate. So it is more just about being more precise and refining it to pin down what exactly it is. But I think also with these data analysis projects is that you can start with answering simple questions and then realizing that the data that you have can be used towards answering more complex questions that maybe you need to integrate some other sources into and go from there, right? And just like iterate over that. So you go from like more simple questions and iterate to more complex questions. So that's my idea. I wonder if that's shared by the author of this book. If you feel nervous when starting to solve an actual data analysis problem, even after learning the basics of Python and Pandas, then this book should boost your confidence. That confidence will go a long way towards helping you analyze your own problems and projects, right? So, okay, so let's see. A little notes about the author here. He graduated from data education and started working as a data scientist, shocked at how different the job was from what expected based on the studies. Data harder to come by, I can imagine. And I listened to the podcast. So he has a podcast. Let me bring that up. Forget what it's called. It might be the Well-Grounded Data Analyst. I don't know. Half Stack Data Science is David Asboth and Sean Revere. So they talk back and forth. Oh, don't want that running, but yeah. So they talk about some of these problems and data being hard to come by. He talks about there. David does about it's about convincing others in the administrators in your organization that you need this data, that you need access to certain data, and they might restrict you at first, be like, well, are you sure you need that? Because it can be quite expensive to access data, especially from cloud services and stuff where they charge you for like outputting data. So and like offloading data, there's usually no charge for cloud services to onload data, but there's charges to offload data. And so it can be, and to run the queries as well, to run the compute, can be expensive. So you have to make a case that like you need the data and it's gonna solve a problem. In some cases, in more bureaucratic institutions or bureaucratic companies, especially like larger companies. And yeah, I guess with like startups, you can just go to the CEO and be like, I need this data. And yeah. Okay, so let's see. When he got hands-on data, it was undocumented, full of problems. Nope. Undocumented being that there's not a data dictionary and stuff, and you have to figure out what's going on with every single field and explore it. Yeah. And full of problems being that it's dirty, that there's some validation issues, and they're duplicates and typos, all sorts of problems, missing data. Yeah, I soon found out I wasn't the only one who had this experience, so when I started teaching data science alongside my day job, I wanted to bridge this gap between the classroom and the real world. Teaching data topics for a number of years now, and the single most frequently asked question asked after the course is, what should I learn next? And based on David's experiences, he says he gives answers to solve real problems learned by doing. Given this answer so many times, I wanted to write it down somewhere. This book is the extended answer. Okay. Improve as an analyst. We need two things: to get better at the process of analyzing data, regardless of what tools you use, and be immersed in a business environment where you work directly affects your surroundings. Okay, business environment. Yeah, I mean, okay. Not necessarily. I wondered like why it needs to be business, but I guess like business being like business, the business could be the government. I guess. Market saturated with introductory material, of course. Yeah. Introduction to data science analysis books and courses are everywhere. What has always struck David was the lack of follow-up resources, of course. What about intermediate and advanced data science? Everything that's out there is exclusively about tools and algorithms. That's great, but there's more to data science than the technical details. In fact, the technical details change, whereas the job of an analyst fundamentally does not. Agree. Hard agree there. Analysts need to be problem solvers. People have questions that can be answered with data, and analysts answer them, and in doing so have to solve technical and organizational problems. That's the issue that like, okay. Organizational problems. At a high level, problem solving is the skill that analysts need to hone most after initial training. The best way to do that is to actually solve problems, but what problems and with what projects? With this book, aspiring analysts can continue to learn while creating a portfolio of projects to show off their advanced skills. Excellent. I can use this. As portfolio. When choosing the projects, I was careful to focus on topics that don't normally make it into an introductory syllabus, but come up often in the real world. I also chose real world data sets and made little or no modification. I keep using guy, but I'm reading this as if I were David here. No modifications, so the problems would be true to life as possible. And enjoy solving these problems as creating them. Awesome. Awesome. I'll give the acknowledgements a shot here just a little bit. Took approximately twice as long to write as he thought it would, and it would not exist without the help of many individuals. And most importantly, he thanks Barbara, his wife, supporting him from the moment he decided to write a book. Sorry in advance if I decide to write anymore. Everyone at Manning who made this book, so that's interesting because Manning kind of want to understand structure of Manning Publishing. I would hope that like someday, like maybe in 10 years, I could write a book. That'd be fun. Thank you everyone else at Manning who was involved in the production and promotion of the book. All reviewers taking the time to provide feedback on the book. Right. Yeah, this is great. So I would actually like be interested in doing like live reviews of the book, of books that authors might be considering publishing. So if you're looking for something like that, like I happily will we'll take some time to go through it on stream. Systems and currently works as a data engineer for a wide range of clients across telecommunications, home services, and finance industries. Thank you, Andrew Freed, technical proofreader, for your dedication and meticulous attention to detail. All right, expresses admiration for Reuben Lerner. And let's see about this book. So the Well-Grounded Data Analyst was written to help us improve our data analyst skills and analysis skills, solving real-world problems. It's presented in 8 scenarios that might be encountered as an analyst, each of which are on a topic that is prevalent in industry but often missing from data education. Also provides a framework that can be used to solve any analysis problem, mostly by helping you define the problem properly before you start. So I might need to like go back to like, I don't know, like data education. I feel like I have a good basis, but maybe there's like some things that I'm missing. I don't know. If you notice that I kind of like don't understand something that you would expect an analyst to know, do let me know. You know, just even if it's I appreciate just like short little comments. Just say like, hey, maybe like look into this, Kevin. Like, yeah, seems like you have a gap here. Just check it out. Be hugely grateful for that kind of feedback. So the book is organized into 8 data analysis projects spread across 13 chapters, and each chapter, starting from chapter 2, describes a project, explains the available data, provides a step-by-step breakdown of how you might approach the project, and offers an example solution in Python. All right, so we're going to start with chapter 1, which introduces the results-oriented framework that we can apply to any data problem. It also walks through an example of applying it to a real-world scenario. And chapter 2 contains the first project, which I will hopefully get through today. There may be some buffering throughout the week that I have to do to push back some things. So I did have like a plan in place for this week that I kind of like want to hit those benchmarks, hit those milestones, but I also want to make sure that I'm understanding things and make sure that I do a thorough job of completing the projects, or at least like to a sufficient level, and then come back to them maybe at another time. But at least get the bare bones of a project complete. At least through like 1 or 2 iterations. Like, yeah. Right, and then chapter 3, which we'll go on to tomorrow, is data modeling. Customer information needs to be retrieved and deduplicated from raw transaction data. Chapter 4, we're going to define metrics. So the project requires you to define what it means for a product to be a best performer and analyze the data accordingly. Right. Okay, that's going to be fun. Chapter 5 is going to deal with unusual data sources. The project task is to analyze the changes in the film industry during and after the COVID-19 lockdown. To do this, we need to retrieve data from a collection of PDF files. So there's going to be some challenges here in dealing with data here. Task is to analyze a developer survey to understand attitudes toward and uses of AI tools. Right. I think this is a phenomenal example here. A timely and good example here is the attitudes towards AI tools. And I'm curious to see that survey data. Yeah. I'm looking forward to that chapter. That's going to be next week. I think near the end of next week. Right? Because chapter 6 is going to be... Or no, I think at the beginning. Because we're going to do 3 tomorrow, 4 and 5 by the end of the week. And then chapter... Yeah, that'll be on Tuesday. Should be chapter 6. Looking forward to that. If all goes well. This might just go off the rails. But hopefully 1 project per day should help if I put like full 8 hours towards it. It might take longer. I don't know. Maybe I'm being a little optimistic. But this is kind of a level setting exercise here for this week. Don't want to burn out, but I also want to move quickly. Yeah. So we'll keep an eye on that. All right, so yeah, and then chapter 8, next project, time series data. Chapter 9 continues that, I think. Chapter 10 has a new project, rapid proofs of concept, and then the chapter 11 extends that idea by designing one as well. And chapter 12 is introducing the final project, taking over someone else's analysis, and then iterating on someone else's work is the last chapter. So what does he say about this? The best way to read the book is to start with chapter 1 to understand the framework. Read chapter 2 to get a feel for how the project chapters are structured. For example, before reading any of these example solutions, attempt the project yourself. Right. Of course. That's what I'm going to try. After chapter 2, I suggest choosing one of the projects that interests you. Okay, so maybe I'll just, yeah, maybe we'll change it up from there. But I do think I want to go through the first couple ones. The 8 projects are introduced in chapters 2 through 6, 8, 10, and 12. They do not need to be completed in order. Okay, that's good to know then. We don't have to do them in order. But, yeah. Hopefully they kind of like, I don't know. I guess they can be self-contained, which is nice. So this book contains many examples of source code in the normal. Okay, so this is just standard stuff here. Chapter 2 onwards, the book code. So let's go ahead and let me actually bring this up here. Book code, live book, and then Manning. Executable things for that. So I'm gonna drop this live book into the chat. You can buy the book. There are excerpts in here, and you check that out. The code is also here, so I guess like even if you don't buy the book, you can experiment with some of the code here. Take a look at it. Okay. So I'm gonna go ahead and add that to my resources for today. And then I'm probably gonna take a break before jumping into the first part of this. so we have our links to the book, and let's share that with everyone. Okay, so I think I'm going to set up the first chapter. Live book discussion forum. You can do that at the live book discussion. I guess like... Where's the... Oh, I guess I have to sign in. Sign in. And I thought there was like... I don't know. I thought there was discussion. I don't see discussion. Oh wait, there's a pop-up that's blocked. There it is. Okay. Yeah. Okay. Cool. So you can do this. You can use this to discuss as well. So maybe I'll just product Asboth. Okay. I'm gonna copy that and paste that in here as well. So that's the link to the discussion forum as well. So let me paste that into my notes here. All right. So you can read along with that, and we're gonna get started. Actually, let's just go through this first couple pages here. I think I was gonna take a break and go for lunch and then come back. So David Asboth is a data generalist. Currently works as a freelance data consultant and educator with an MS in data science, and has a background in software and web development in various industries. Previous roles included a range of data science, software development, and software architecting jobs. Latest interest is figuring out what skills the analysts of the future actually need to succeed. Beyond having over a decade's worth of technical experience in multiple industries, David co-hosts the Half Stack Data Science podcast. I'm going to share that link. At least to the... wait a minute. Yeah, there it is. Okay. Share that link in the chat as well. It's Pocket Casts, and you can also go to halfstackdatascience.com as well. Check that out. So you should be able to see this live chat on the replay. I think I have that set up. You can also add comments after the fact, I think. Once it goes public. I think that still works. I don't know how that works. But in any... Well, yeah. I don't know if that works. Okay. I want to close that down there. So I might like listen to some of his podcasts at some point on stream as well. Okay, so where were we? So he has the podcast about data science in the real world, spoken at multiple conferences, including the Data Science Festival in London. So, yeah, he's qualified to speak about this stuff, okay? He knows his stuff. That's all this is, including large banks and consultancies. David has taught hundreds of students introductory data science over the years. Wanted to write a book about what he thinks students should benefit from after learning the basics. The figure on the cover. A Hongwa, a Hungarian. taken from a collection by Jacques Grasset de Saint-Sauveur. I can't pronounce that. I'm bad at French. Published in 1788, each illustration is finely drawn and colored by hand. In those days, it was easy to identify where people lived and what their trade or station in life was just by their dress. Manning celebrates the inventiveness and initiative of the computer business with book covers based on the rich diversity of regional culture centuries ago, brought back to life by pictures from collections such as this one. Well, I hope they don't just take a Western view of that either. Should bring in some other cultures as well, and even the global South, even with African cultures as well. I have not seen those with Manning, but I would expect that they could come up with something there. So I'm going to take a break. I'm going to go for lunch, and we're going to come back, and we're going to do this first chapter of the Well-Grounded Data Analyst. So be back soon. Let's see if this works. Righty, coming back in here. So gonna go start on the Well-Grounded Data Analyst. I'm not sure what I need to prepare for here in the first part here. I don't think there's going to be any code in the first chapter. I'm probably just going to be taking notes. I guess there's a little bit of code in chapter 2. So, yeah. So, first part's just going to be reading, I guess, and taking notes. And let's see what I can do with this then. So we're going to come on over to our notes over here. We have this one here. I wanted to see, how do I, is there a way to cite the book? Just want to find that out as well before I get started here. Probably at the appendix. Let's go. Index, appendix. Let's see, probably at the end, I guess. Summary of projects in the book. That's interesting. Yeah, I don't see it there. I guess yeah, maybe it's online. Maybe it's online. I like that the Manning or O'Reilly gives you the the little snippet for citing the book. What about sharing? Link copy to there. Yep, I don't know. Okay. Just have that in the back of my mind until it comes up. My 3 main takeaways. I don't know. What are the 3 main takeaways? I think I gotta change that note. It's not really what I'm going for here. It's for some other stuff there. Okay. All right, so let's dive in here. Chapter 1, Bridging the Gap Between Data Science Training and the Real World. It's going to cover approaching data analysis using a results-driven process, and we have the image that we're going to come back to every now and then here. And I think this section is going to be divvied up in that way. Yeah. So I think what I want to do is to make my notes here. Let's see. Yeah, well-grounded data analyst. Chapter, I don't know, chapters. Yeah. Yeah, I don't know. What do I want to put under here? What did I do for the other one again? I don't remember. I guess I'll just like keep a... Yeah, just a note on the... I don't know. It's going to take me a moment to... Take me by the end of the day to get back into my note-taking. So we're going to focus on pragmatic solutions when analyzing data. And, important data science concepts using true-to-life projects. So I'll try to take notes from there, I guess. And anytime something comes up. Actually, let me look up data analyst in my... Oh, I've got notes and role. Yeah. Data analyst as a role as well. This is where I have the keys, the responsibilities, gather data and skills and technologies. So I think skills is we're gonna like take a look at the toolkit from there. I'm gonna add to that note, right? Okay, does the following scenario sound familiar? You've just received a data request from a department in your organization and you have no idea how to handle it. Perhaps even exactly what you've been asked to do. Outside the structured experience of your initial training, the real world is messy and uncertain. You may be wondering, how do you use your existing skills to complete projects for demanding stakeholders? How do you keep learning now that the structured training environment is no longer there? Yeah, exactly. How can you apply your general skills to domain-specific tasks? So, like, this is like where mentoring used to come in, right? And I guess like that's a thing of the past now. Everyone's just expected to know how to do these things or to learn on their own without having much guidance from a senior. How can you apply your general skills to domain-specific tasks? And what do you need to learn next? All right. Yeah. Any senior data scientist will tell you the answer to all these problems or these questions is experience, but by completing the 8 projects in this books, we will accelerate the process of getting the experience we need to succeed as a data analyst. And so we will hone our existing skills and learn new ones by completing projects similar to those that may be encountered in the real world. And as we go, we will do most of the work, but ideas will be provided to get us started. To augment the specific skills, he also lays out an approach to make a better analyst out of me by focusing on pragmatic results. Along the way, you'll follow a process to make it easier to learn skills efficiently and get the most value out of each new challenge that we face. So the data analyst's toolkit. So this is let's I don't know what type of call out I'm looking for. Yeah, it doesn't say. Which callouts do I have available to me? That's what I wish that we knew how to do. Is to like find. That's one feature I wish. Select a callout. I'm gonna go off on a tangent here for a moment. And oops, sorry there. Okay, let's go. Let's see. All right, when you right click a call out. Oh, but it's only in live mode. I don't like that. I don't like that one bit. Why only in the... Let's try this. I don't know. Does it work for... Yeah, I just want to, just real quick, let's just try to get this community plugin here, and we'll do a check here as well. And let's go call out. Create and customize callouts. That's pretty cool. What is this thing called? Called out menu. Create simple callouts and lists. That sounds awful, honestly. Oh, actually, wait a minute. Excuse me one moment. All right, so there are certain fundamental skills analysts learn. Let me see. Let me get this first. On the options here, so... Oh gosh, this is awful. Okay, so I still need to do this. Metadata types should appear in the context menu. I don't even know what that means. Back to appearance. We'll open up the callouts and community plugins, and then we'll go to the callout menu. Before I do that, I think I actually just want to make sure that it'll work. So it only works in live preview mode. You can change it to something from there. Oh. Okay. Is it example? Is it summary? Abstract? Info? Why do I have example on there twice? It's weird. Example and site. I think summary's on there twice too. No? Questions on there twice. Strangely. Weirdly. Okay. I'm just gonna go with an info. Back to that. Okay. Data Analyst Toolkit. So, for certain fundamental skills learned at the start of the so these are the ability. So let's make sure that we like kind of understand this. So, read in, and it's to load a data set from a variety of sources, right? Okay. So this is handy to go through as a list of things I need to like list on my resume. Joining data sets together, you know how to do that with merges and stuff. And joins, inner joins and outer joins, left joins, right joins. And you need to be able to manipulate columns by creating, deleting, renaming, and transforming. You need to be able to perform basic statistical analysis, such as calculating averages. So yeah, you know those basic stuffs. Yeah. Explore data using visualization. So we've done some of that already. With bar charts, line charts. I'm going to say and scatter plots. Or scatter plots and scatter plots. So you want to be able to present findings by creating appropriate visualizations or designing dashboards. I wonder if we're going to get into some dashboard creation here. And so here we go. Like we have this list here. So let's go ahead and say that these are fundamental skills. So we'll call that like that. Fundamental skills are that. Okay, so which tool you feel comfortable using for these tasks does not matter. So I'll also just take in, so technologies is where we're going to do this. So this is with like tools, right? So the data analyst toolkit, and we're going to say tools. And the, yeah, I'll list that under technologies. So, I mean, you can use Microsoft Excel or an equivalent, right? Like OpenOffice or LibreOffice, which, what is it called? Calc, I think is the sheet one. LibreOffice Calc, yeah. Which I think comes, like, I installed a Linux Mint on my old laptop, and it came with like LibreOffice like right out of the box, and that's pretty fucking cool. That like, right? So that made me feel good about my choice to stick with that rather than OpenOffice, because it seems to be the preferred software, at least amongst open source community. So it makes me feel like there's going to be some more support in the future. Business intelligence BI tools, such as Tableau or Power BI. And should have some knowledge of database query languages, right? Those technologies such as SQL. Though typically don't have visualization capabilities, right? And then programming languages with data analysis capabilities. And that's going to be Python and R. And then the example solutions to the projects are provided in Python, but the focus will be on problem solving, not the specifics of the Python programming language, which is where my knowledge needs to come into play there. We'll definitely be stretching our brain for those problems if they're not explicitly listed out. Completing the projects will build our foundational skill set by adding skills specific to real-world use cases. And that includes data modeling, working with categorical data, extracting data from unusual sources, and rapid prototyping. So in each case, we'll highlight the exact kind of functionality required to solve the problem so we can find the appropriate way to do that with our preferred tool, which for me is going to be Python. And some of the projects are going to use machine learning models, but in-depth discussions about machine learning are beyond the scope of our projects. The projects will also let you hone more meta skills, which are vital for any data analysis project. So these skills are the ability to take a human question. Okay, so meta skills. Let's see this. Okay, so this is going to be inside there. All right, so I'm going to put this underneath there. So meta skills. Fundamental skills or foundational skills. And then we're going to have, let's see. Let's put meta skills, which we're going to have. Take a human question. And that is fake. Contains no technical jargon. Translated into one that can be answered with data. That's a challenge for me as well. The available data. Whether it's suitable for answering the question. Need to know how to pivot your analysis and change your analytical question. It cannot. If it can't be answered with the available data, maybe we need to alter our question, right? Communicate results to someone with no knowledge or even interest. Well, that's going to be a challenge in the technical details. Okay. Well, yeah, that's what makes you a good senior, I guess. Practice projects focus on building technical and problem-solving skills. There are other professional skills needed for a good data analyst if we want to dive deeper into these, and I recommend to build a career in data science. Oh yeah, that's one book that I'd like to read as well. I think that's Emily Robinson and Jacqueline Nolis. Which, speaking of which, uh, um, is Jacqueline on Blue Sky? I would suspect she is. It might go by Jackie Nolis, I think. Ugh. Okay, that's weird. Maybe she gave up altogether. Maybe she's not on Blue Sky. I'm surprised. If Emily Robinson is on there. No, there's another Emily Robinson that's a historian. Yeah, 'cause she's Data Pros. Right, yeah, that's her. Okay, I should follow her on whatchamacallit. There. Yeah, I guess she's not on there. I'm surprised by that. Fanatics. Build a Career in Data Science is another book that I wanted to read as well. It is kind of more geared towards people with a PhD, though, as from my understanding. Okay. Novo Holdings. The hell is Novo Holdings? Sounds financially. Private equity. Okay. All right, so let's get back to this because I wanted to read that. I wanted to read that book. Yeah, okay. Future of data analysis also includes artificial intelligence tools such as ChatGPT and similar large language models. AI tools cannot replace your ability to think critically, communicate with stakeholders, or work within the constraints of a business environment. However, AI tools can accelerate your work by helping you automate the more mechanical aspects of a project. I will highlight instances where such a tool could help solve a part of your problem. For example, if you don't know how to read data from a PDF file, an AI model will be able to tell you how to access this functionality in your preferred tool and give you code snippets to use. This means that you can solve that particular subproblem faster, which will make you more productive. Whatever. So uses the term data science and data analysis interchangeably. Well, that's not, I don't really, I think there's a distinction to be made. Let's see, first and foremost, data scientists need to be good analysts. So he prefers to use the phrase analysts or analysis instead of data science to describe the discipline. And analyst instead of data scientist when describing the practitioner. When he uses data science, it just means the process of analyzing data. And refer to the real world a lot, and the reason for this is to emphasize the disconnect between what you learn in a classroom versus what an analyst job looks like in practice. And this disconnect doesn't mean classrooms are bad. There are simply multiple, not necessarily technical hurdles to overcome that cannot be taught in a classroom, and the focus is on preparing junior analysts for their jobs by teaching them all the things they couldn't have learned in the formal training. And real world is outside a learning environment, so similarly, the word stakeholder is also a loaded term used to mean your boss, an internal client, or an external customer. They're the originators of requests that generate the work you do. A stakeholder is anyone who is the target audience of your analysis, will be directly affected by your work. All right, so we're going to look at the results-driven approach. And honestly, I think what I want to do is to make a separate note of this. So this is good. We have some things to come back to when we want to highlight our resume. To what I need to highlight on my resume to demonstrate that I know these things. Because I feel like I do know these things. I just need to put them into words, put them in there. Let's see. And then I want a real thing. Oh, before I do that, let me add the notes that I used for today. So we used that one. And we used the roles as well. And then, let's open up the inbox because we want to. Oh, weird. Oh, maybe it's already there. Yeah, okay. It's already in the right folder. Let's see here. Yeah, it is. Okay, let me go back. I guess when I duplicated it, it duplicated it to the same file level, folder level. Okay. So that's definitional notes there, and then this is the role, data analyst, and then it's what I want to come back to when we do that, and then we want to data analyst, and I also want to do a file called So on the job, our success depends more on the results we deliver than the skills and knowledge that we bring to the task. Being results oriented means that our focus is always on problem solving. We should arrive at a first draft solution as soon as possible. Something like to call a minimum viable answer, which is interesting, right? It's a take on the minimal viable product. Presented to the stakeholders and used as a basis for future iterations. Oh, and if you follow me on Blue Sky, David Asboth just shared a promo code for the book that I'm working through right now. It's 45% off until February 26th. So do try to take a notice of that. So yeah. Okay. Minimum viable answer. That's a funny take on the minimum viable product, I think. This is what you present to your stakeholders, a basis for future iterations, and applying this thinking streamlines our work and delivers an immediate value. Spend time learning. Let me highlight this. Spend time learning something that will be immediately applicable, get a higher return on the time we invest. And so with this results-focused approach, we don't need to be an expert in everything up front. Instead, by completing each project, we add new specific skills to our toolbox and learn a method for approaching new tasks efficiently as we go. The results-driven approach I present means practicing learning by doing and working in a results-focused way. Okay, so if you look at this approach through the lens of a classical example from industry, suppose we work for a car dealership. They need to answer the seemingly simple question, how many cars did we sell yesterday, for the manager? In an ideal world, this is a simple business intelligence question that requires nothing more than filtering a sales table down to just cars sold yesterday and providing an answer. But the reality is that you need to think deeper about the problem, starting with defining the terms before we begin. Okay, so the first part in this is to understand the problem, right? So we'll do, I'm going to do bold. Understand the problem, right? And then this is, there we go. Includes definitions of individual words and concepts. Right. What I like about this approach is that, like, it's kind of like, it's good for people like me who are kind of like, I think, on the spectrum. So having a structure to something really helps to build confidence and make sure that you're like on the right track. And then starting at the end is, what is a minimum viable answer that could spark further conversation? And then third part is to identify additional resources. Okay. Oopsie. I somehow added a ligature or something. There we go. So they can be data people or access permissions. I think we could call it the MVA, right? Okay. And then what we want to do next is to obtain the data needed to get minimum viable answer. I think minimum and minimal could be also minimal viable answers, like, because like anything, well, yeah, because like minimal has the notion that, like, if you remove even one little piece of it, then it ceases to be minimal, right? It ceases to be viable then. Yeah. Whereas like minimum viable could be, like, it could still be viable, but like you just like your definition of viable is different. I don't know. It's just a weird thought I had. So ideally, this step shouldn't take more than a few days. I'll say to facilitate iteration. And so do the work to get, I'm gonna say the MVA, right? To get the MVA, minimum viable answer. Oh, okay, that's why it didn't quite make much sense. So I was gonna say, like, obtaining the data might take a while. Does this data even exist, or do we need to create it? Do we need to get surveys? Present the MVA to a stakeholder and get feedback, right? Could be anything from your boss. Casual conversation, good presentation to an audience. And then we want to iterate. If necessary. If the work is valuable, you must be malleable. Oh yeah, if the work is valuable, stakeholders will also will ask you to pursue it further. Okay. Figure 1.1 is a visual representation of this process, and notice that the arrows going back from step 7, they highlight the nonlinearity of the process. Depending on how step 6 goes, you might need to go back a further to an earlier step. And then, so I also want to put the image up on here. So I thought, yeah, let's put that up down here, I think. Here it is down there. Yeah, there we go. Yep. I wish this was like side by side. That would be nice. This could be a good flashcard to do, is to, you know, memorize the process there. So you're going to understand the problem. What do we mean by car? When I worked in the automotive industry, I didn't work in the automotive. When David worked there, every time a question about vehicles came up, I have to clarify whether that included vans or other vehicles that weren't quite cars. Sometimes vans were relevant, sometimes they weren't. Then what do we mean by yesterday? Yeah, often several dates could be associated with a sale event: the day the customer bought an item in a store, the day they invoiced the customer for an item, the day the customer paid, or even the date a sale-related dispute was resolved. So when we asked about yesterday, need to know which date column to use. Even the word sell can be ambiguous. What if a customer returns an item later? Does that mean the answer to this question changes over time? Right? We might explicitly decide that what happened in the past isn't fixed, which will make our analyses more complicated. Incidentally, we should codify answers to these kinds of questions and record them in business-specific data models. And we'll get to that in chapter 3. And so the output of this step should be a clear question that can be tackled with an analysis, a defined scope. Does the analysis of cars also extend to vans? Clearly defined terminology agreed on by those involved. So let me go ahead and do this. So what I want to do say from this, because I want to take 1.2.1 and I'll say understand the problem. Yeah, I think I'll do it like that. And output of this step could be a clear question and be tackled in analysis. And we're going to say related to. Should have a defined scope, right? For example, does the analysis of cars also remains? And we also said this meaning of the day. Terminology. What those involved, and so these items should be documented as part of the project for transparency and reproducibility. Once we have understood the requirements, should move on to envisaging a solution. Fun word, envisaging. Envisioning, envisaging, putting a face to it. Start at the end. So to start at the end, what should the output of this step? So we're going to talk about deliverables as well. Document, presentation, or working proof of concept, right? Once this is understood, the next step is to identify the required data. All right, so assuming we have agreed on terminology, we start at the end and right, decide what a minimum viable answer looks like, and this depends on the nature of the quest. What our stakeholders want to do with the information. If it's a quick ballpark estimate we can sidestep some of those difficult questions about vehicle types and dates unless we have a good data model to pull from. Knowing what level of answer our stakeholder expects is crucial to deciding how much effort the request warrants. Right, okay. Okay. So then even for simple requests, it's important to ask what data would we need to answer the question, immediately followed by, do we have this data? Okay. It's advisable to research the available data before committing to any work, because there are cases where we don't just have a data set that directly records the concept we're interested in. And for example, in an online auction marketplace, sales transactions might not be recorded directly as they could take place outside the system, okay? And they might be recorded later. And we need to know where a record is made if a sale is agreed over the phone after the auction takes place. And the output should be a list of what the appropriate data might look like to answer the question. Okay. I am just about ready for a little bit of a break. So let me see how much further we have to go. I might, take a break before we get to project structure. Yeah, we'll just finish up this section and then I'll take a quick little break there. So we want to obtain the data and the output of the step. So we either extract it from somewhere or create it, right? So if our online auction marketplace is only used for listing and bidding, we might have to make do with inferring when something was sold by seeing when it stopped being listed. This is a data set we would need to create from the raw listing data, right? In this case, we would have to stop at step 3, which is to identify additional resources and regroup to figure out whether creating such an inferred sales data set is worth the effort. This will depend on the minimum viable answer we define in step 2. So the output should be a tangible data set or extract, which can be used to get our minimum viable answer. I'm going to say MVA for minimum viable answer, as you would usually say an MVP, but we'll say MBA. If it's not the Motor Vehicle Association or whatever, or Motor Vehicle Administration. I think that's what what New Jersey has now. It's not DMV, it's the MVA, the Motor Vehicle Administration. If the data is only an extract, it should be representative of the larger data. Okay, so then the output of this, of course, if at the end of the obtaining the data, you don't actually obtain the data, then I guess, you kind of failed at that step. So, obviously the output should be a tangible data set. Or extract, which we can use to get our tangible data set. I'm going to say data set. I think what he says when extract, I think when he says extract, I think he means sample. Right? Representative of the larger data, so that like you have everything represented. So that if you have categorical data, you have every single category represented in that data. If you have numerical data, you have a sufficient range of data represented there. That is similar to the larger data set, right? So and you do that from sampling, right? so you do that from random sampling. And then we got to do the work. Output of this step should be, let's see what we're going to do here. And notice that step 5 just says do the work. This is intentionally broad and vague. Step 5 might encompass the entirety of other data analysis workflows that have been encountered, right? With steps 1 through 4 ensure that the doing part will have a higher return on investment. Okay. And by this point, we've given the problem enough thought that we're not just aimlessly jumping into writing code, which is certainly a temptation when our skills are fresh, and we're eager to deliver. Encourage time spent on steps 1 through 4, perhaps even more than you would instinctively do. Right. Instinctively spend. Okay. So, in the car example, during this phase, we might find that the sale date of a vehicle changes over time based on events such as a customer waiting for a finance agreement to come through, or previously undisclosed faults were subsequently noticed and the customer raised a complaint. As the analyst, we should not be making the decision alone about which possible date constitutes the actual sale date. So I'm gonna yeah, that's just too specific. I like to highlight things that are a little bit more generic for like examples like this. But generally, the idea here is that we shouldn't be assuming things on our own. We should be getting feedback. Right here, you go all the way back to step one to have a conversation with your stakeholders before continuing your analysis. Your analysis. So whatever happens in the analysis, documenting our specific choices and assumptions is critical for transparency and reproducibility. In the example solutions presented for each project, we've documented the specific choices made and where another analyst's path might have diverged. Had they made different decisions, and so the output here is whatever was decided in step two. Right. And that is the deliverables. So it's really like deliver. I'm going to say deliverables. And then we have to present, right? Present the MVA. A key component of the results-driven approach is presenting results earlier than we might be inclined to. Looking for a satisfactory solution, we should be discussing preliminary results as early as possible to allow iteration. Data teams have failed in the past when they siloed themselves away from the rest of the business, only to emerge months later with work that no one asked for and has no tangible business value. Yay. All right. I need more water. I need to stretch out. I need to take some ibuprofen here. All right. So the question here is anyone using your work? Once sat through an interesting presentation at a conference where the data science team had built a complicated sales forecasting model. The presentation was purely technical and told the story of how they arrived at their hierarchical Bayesian approach. In the QA portion, he posed a difficult question. Does anyone use your forecasts? And if so, what for? The data scientists sheepishly admitted they're still working on convincing the business that their forecasts are worthwhile. They suspected a lot of needless work could have been avoided had they engaged in that conversation sooner. Right, but I mean, you gotta get paid. I mean, yeah. I mean, they want to justify their paycheck, but I mean, just let folks eat sometimes, you know. The output of this step is minutes of a meeting with or presentation to our stakeholders. Outcomes should also be recorded as part of the project. Okay. Again, we're doing... Okay, that's weird. Minutes of a meeting with stakeholders. Creative for stakeholders. And so this could be a slide deck. This could be a video, right? Yeah. And then we got to iterate if necessary, right? I think we might be buffering here, so would be a good time to take a break, but I'm just going to try to power through this one section, this subsection. Well, looks like we're back, but that internet is acting up at this time every day. Finally, you will almost always end up iterating your first answer, and so it's an important step to include in any analyst's framework, right? Because highlights the inherent uncertainty of the job, and you never have all the answers up front, including the answers to the question, how long will this analysis take? And that's fine, except that a first draft will be necessary to reach a satisfying solution, and the sooner that first draft exists, the better. The added benefit of this iterative approach is we become better at estimating how long the work will take, because we only ever have to estimate one iteration rather than the entire project. Right. Okay, that's fun. Right, okay. Yeah, so you get an answer, and then you have to kind of take it back, and then you have to refine it, right? Using a results-driven approach will help us develop an intuition for how to make analytic decisions that help us focus on providing a pragmatic solution rather than an unnecessarily deep answer up front. And so, of course, we need to learn new tools along the way. So sometimes these tools will only be used for the analysis we have in front of us, but the next analysis may need different tools, and that's okay. Tools come and go, but the knowledge and concepts you learn will remain the same, and these are what make you a good analyst, right? Right. Okay. I'm going to highlight that. So it's important to note that this approach is not a substitute for going deep when necessary, encouraging anyone to take shortcuts. However, a key skill in analytics is identifying the highest ROI on our time, which often means adopting a breadth first rather than depth first search approach. Right. Interesting. Okay, so I want to highlight that. It's pretty interesting. So then the output of this, so I'm going to paraphrase David here and kind of try to synthesize what he's saying with my understanding here. I'm going to say like the output of the step here, with iterating if necessary, would be to a decision. A decision should be made at this step. A decision to refine our answer or quit, basically. Basically that. Decision to refine our answer or to quit. Is this worth pursuing, right? Is it worth pursuing further? That's the output of that step, right? Iteration, if necessary. Because obviously, like, the iteration is just to go back to the start. So it's kind of like there's two views that I think might be at play here. Let me come back up to here. Let me try to see if I can get up in here. Okay, there we go. Right. Okay. So follow me here. Follow me here. So I think there's two things going on here. I think one approach could be to iterate if necessary, meaning that we're encompassing all steps 1 through 6 and packing that back down into that step there. And if we go back to the image here, I don't know if that's what David's getting at here. I think that what you're going to do here is iterate if necessary. Is you're making a decision whether or not you want to go back to refine your answer. And that's why I'm saying, like, the output of this step should be a decision to refine our answer or quit, right? I don't know why. There I am. I don't know why I just disappeared. Oh, I know why. Yeah, because okay. Never mind. There's so many little bugs. Or not really bugs, but just like corner cases that I didn't consider when setting up my automations for showing my video on screen. And I guess one of those is moving from... Yeah, one of them must be when I hit the button to go back to the full screen video and then go right back to the same screen that I was on. It's not triggering it. I think that's the case. And then I had to like switch off of that screen and then go back to that screen, and then that triggered it to come back on. So yeah, I'm going to take a quick break and then we're going to go over project structure because I think we want to fully understand this part. And I guess it's really just for the book, the project structures for the book. But I want to understand this, and yeah, so before I take that quick break, I'm going to just add on my results-driven approach to data analysis, and then we're going to move this to job notes. Right? Okay, there we go. There we go. All right. I'm going to take a quick break. It's going to be 10 minutes, I think. All right, coming back in. Let's get started with project structure, and then I'm going to dive right into the project. So, do I want to keep a note on this? I'm not sure. Because I think this is really just specific toward... Yeah. Okay. Yeah, I think this is just specific to the book, just by looking over this. So projects are designed to represent common problems, right? It's designed to be approachable with fundamental analyst skills and not take too long. There are lots of factors at play: the level of experience with your tools, your familiarity with the topics at hand, and the speed at which you learn new concepts and so on. But generally, the first iteration of your solution to each product should take somewhere between 2 hours and 2 days. Okay, hopefully. Let's hope for the 2-hour one for the first one. Because I really don't have that much time here today. But if it goes over, I'll pick it back up tomorrow, and we'll like I said, there could be some buffering this week that needs to take place in order to keep from burning out, basically. I'm I will try to get these things done on schedule, but it may have to push things over, and they might bleed over into other days. But and I might not update the the descriptions of the videos and stuff. So just be forewarned. That could happen. So there's a lot of factors to play, right? And then so it's a broad range, but a 2-day sprint to deliver something you can discuss with the shareholder would be considered a quick turnaround time. And also, these are really just like small real world problems, right? So yeah. So the projects not only reflect common industry problems, but are also designed to bridge specific skill gaps between initial training and the real world. And table 1.1 is an overview of these projects, right? The summary of the 8 projects. And I think this is put into the back in the appendix. It's where we looked at those as well. Analyzing customer retail spend in different geographic areas. That's going to be interesting. I'm kind of curious about that retail stuff. Extracting structured data from free text will be the skill that we flex there. We're going to flex data modeling tomorrow, where we extract unique customer records from e-commerce transactions. And then on Thursday, we're going to define metrics with the project defining and finding best performing products on an e-commerce store. So I'm interested in that as well, in e-commerce. Analyzing the effects of the coronavirus pandemic of the film industry, time permitted, for Friday. It would be extracting data from PDFs. So, I mean, I'm interested in all this stuff, and like handling categorical data we'll do next week with investigating developer attitudes towards AI tools from a survey. And then I think the week after that, we're going to work with time series data. And actually, I think we end next week with starting with like working with time series data with chapter 8, and then it bleeds back over to chapter 9, I believe. Right, if my knowledge of the schedule is complete there. I think that's right, because then it's 9, 10, 11, and then the last week will be 12 and 13. So yeah, I think that's right. Identifying potential improvements to cycling infrastructure. We're going to do that in the next week and the beginning of the third week. And then beginning a proof of concept application to explore the Welsh property market is the rapid prototyping. Yeah. All right, 1, 2, 3, and then fourth week. Yeah, and then the fourth week we'll continue another analyst's work and create customer segments using a mobile phone activity. So each project is structured in the following way. It starts with a high-level description and the data. Beyond that, we're on our own. This section is sufficient to read if you either feel more comfortable formulating an action plan based on a somewhat vague analytical question or want to practice that skill explicitly. And so what follows is a more detailed step-by-step breakdown on how you might go about attempting a solution. So there will be no code snippets here, but if the high-level description has us stuck on where to start, this section should help kickstart the solution attempt with a breakdown, right? Yeah, so like we can just go get some hints, basically. And finally, we'll always, an example of a solution is always included. There will be discussions on how we can go about attempting to solve the problem, but what assumptions we have to make, how we might change our analytical question given the constraints of the data, and what an acceptable result will look like in the example solution. Specific assumptions and decisions are maybe different than ours, but that's to be expected. The goal is not that you arrive at his solution, but the solution. It won't be the solution, right? So you'll highlight places where the analysis may have diverged. And the goal is to practice going from problem definition to a minimum viable answer. And so hopefully get some good practice with that. So to consider this collection of realistic analysis projects as a practice companion to help get used to diving into something without knowing the answers or even required tools up front. And when learning through practice projects, we have an end goal in mind, we work towards it, we learn the skills necessary to get an answer rather than learning skills with no real end goal in mind. Yeah, that's been kind of the way I've been going. So I kind of want to like solve some problems. So we're going to learn breadth first, not depth first. Okay, I'm going to highlight this. Approaching projects using the results-driven method will prepare us to apply these methods to any project, and these projects should inspire us to continue in analyzing data and use this solve a problem framework for learning, all while accumulating new skills and building a handy portfolio to show prospective employers. That's if you're watching. Yeah, please hit me up. Check me out on LinkedIn. I think I have my LinkedIn in the in the chat. Check the chat. Add me on LinkedIn. And if you're a viewer and you're watching and you find me on LinkedIn, if you connect to me, please let me know where you're coming from. You know, I don't really accept connect requests if they don't have a message along with them, unless I know the person, unless I know you. So if I don't know you, then please let me know you. Let me know that you watched this video. Be helpful to know which video too. So for a summary, let's go ahead and add in our like key points here. So there was like key ideas at the end of the O'Reilly book chapters. So at the end of here, let's look at summary. Yeah, let's go to the summary, and what we'll do is we'll just make a list from here. So expect a gap between your formal data science training and the real world being pragmatic. And results-driven helps navigate the inherent uncertainty. Data analysis. We've got to focus on problem solving. We're going to create a real world project portfolio. That's kind of like my goal at the end of this. I'm kind of using this to get the yeah, that sounds good. I want to stand out as a candidate, especially given the lack of formal education in the higher level, right? Yeah. Did not get a master's. Did not get a PhD, and subsequently, right? So let's jump in to this. Looks like we may have lost the playlist here. No track radio. So we got all the way back down to the other stuff. From the answer. Yeah, I'm just going to shuffle again. Going back around, we're going to shuffle Josh's playlist again. There we go. All right, so we're going to encode geographies. And so what I'm going to probably do is to start with a... I think what I'm going to do is to have a subfolder. That's probably what I want to do. Let's get a subfolder up in here. I want to get rid of that. New building. I'm probably going to delete that plugin. I don't know if I'm ever going to use it again. So chapter 2. Let's see if we have any data that we need to get. Okay, so I think what I'm gonna do the wrong one. Yeah, I'll just leave that open. Okay, so what I want to do is to create a... Oop. Hang on a second. Excuse me. Yeah, sneeze. We're going to create a folder for chapter 2. The and we'll call it... I'm not going to split it up by chapter. I think I'm just going to do it by the name, Encoding Geographies. Because they don't need to be in order, right? So... okay. Yeah. And then so I think what I wanted to do was do something here. And I think what I'm going to do is to do data. I want to create a folder or a file at here. And what I want to do is call it data.py. And alongside that, what I want to do is to do, let's see. I wonder if I wanted to call it .data. I don't know. Maybe I do. Maybe I want to just call it .data. Yeah, I think that's what I want to call it. I just don't want it to be doing that. So what I'm going to do is inside here, this is going to be, whoops, I'm just going to set up a folder for a bunch of whatchamacallits here. Organized imports. Yeah. Okay. Oh, wait a minute. Okay. I want to make some like enums or something for the path. Path variables. So what I want to do is to call this the data directory. And what we're going to do is call that so that way, like I can just import the data.py into my thing. I'm pretty sure. I'm just going to figure that out later. But what we need to do is to import pathlib. No, from pathlib import path. That's it. Okay, and then path is going to be, we need to import OS as well. So importing OS, we need to do os.getN. Or actually, do we have a get environment variable? I think it's like get CWD or something. Wait. Is it just... Oh, it's just CWD. Current working directory, and then we're going to say data. I think that's it. Let me see. We don't need OS then, right? We don't need that. That's all we need. We just want to print that. And so from here, we just want to do Python. Oh, wait. Yeah, that's it. That's all I wanted. And then so... That's all I want. Basically, just have path variables. So when I go into like this folder and I create something, so I want to do like a code thing from there. That'll come up later. You'll see why I'm doing that in a minute. Just to set up my structure for the thing here. So I can like handle like the data for all of the projects, basically. So we're going to use the results-driven approach to tackle a real problem. We're going to make an analytical decisions in the face of uncertainty. Isn't that wonderful, right? So now that we've been introduced to the results-driven approach, let's apply it to a real data task, and we'll tackle a real-world problem and apply the results-driven method to it. And so it's a template for approaching the other projects and any other project that may be encountered in the future. And so all of the projects and data are available at https davidasboth.com. Book code for us to attempt ourselves. So there will be data sets for the project and example solution there in the form of a Jupyter notebook. And so for this chapter's project, we're going to examine an example task that analysts encounter, which at first glance might seem simple enough. It's encoding geography, right? So on Jupyter notebooks, Jupyter is a development environment that allows mixing of code accompanying text in the form of notebooks. In notebook files, let you read the text and run the code directly within the document. And they're popular for education and data analysis. So the notebooks accompanying the book collect the code snippets from each chapter into a single document where the code is also runnable. So if sites such as GitHub even let you view the notebooks in the browser without requiring Jupyter to be installed, you can see the appendix for instructions on how to install Python to run the code ourselves. So yeah, I'm not going to go over that. Sorry, but if you want to check that out, you can check out the book. There's a link in the chat there, and a link on the link in the description as well for the book. I think, did I put the link in the description? I might not have put that in this one. I'll try to remember to do that later. But I do remember that I did put it in there for, I think, tomorrow's description. So if you're looking for that, go on to the upcoming live streams and you'll see it in tomorrow's one. All right, so project 1 is identifying customer geography. So we will extract location information from free text to better understand our customer base. What is our customer base, you might ask? That's what I'm asking right now. As an analyst for Pro Widget Systems, a UK-based B2B retailer, is this a real one or is this a fake one? We've been asked to report on spending volumes for London-based customers versus those based in the rest of the United Kingdom. And the board supplied us with a high-level data extract, I think is a sample, containing all customers' addresses and their total spending to date. They want to know which UK cities are currently underserved and whether their customers are primarily London-based. So what I'm going to do, I'm tempted to put the code alongside the README and do that alongside there. I'm not sure if I want to do that or not, or if I want to just keep a separate one. Oh, I don't want Copilot. Can I get rid of that? No, fuck off, Copilot. Just fuck off. Okay. I don't want to use those. So that might make me a less productive. But the things you're going to get from me are going to be correct, okay? You can trust that I have put thought into it. You want to know which UK cities are currently underserved. So, let's go. I think what I want to do is just to create another file, another folder for this. So, or another file. What am I talking about? So the results-driven approach, we're going to come back to that. But what I'm going to do, I want to say project 1 is encoding customer geographies or something like that. Or it's identifying. So you know what I want to do? I want to actually do this in a Jupyter notebook. I don't know if I want this in here. I think I want this in a Jupyter notebook. I'm going to delete this. We're going to do this in the Jupyter notebook. So let's go over here. And so we're in there. We want to go into encoding geographies. What I'm going to do is to create a file called project 1. Draft final iteration 1. Let's go with let's go with encoding geographies. Project 1 I1. Project 1 I1. How about that for a thing rather than doing some other things? Yeah, because we could do version control with Git. But I feel yeah, I mean you could do branches, and you could do for like each branch, like so you could branch into like end iteration 1 on one branch, right? And then create a new branch and branch off from there to go and do other iterations. That's one approach. And then you just don't trim those branches. You just keep those branches open once you get at the end, right? That's one approach. Or I'm just gonna, so that I can see them side by side easily without having to resort to Git commands. I'm gonna adopt a file naming convention that's gonna say project X, iteration X, iteration Y, Project 1 I1 is the first project. Let's get a markdown cell here. So what we have here is project 1. Going to be identifying customer geographies. Let's do that. And so what we'll do is we'll say like the first part in our in our thing here is like the understanding of the problem. So we don't even know what the problem is, right? Because we don't. So let's split it up into sections here. So the first part, we'll just say the problem, and we're going to try to understand the problem. So the problem is we want to know, and I think we can do a checklist here, which UK cities underserved. So already I'm seeing like, what does underserved mean? And we're gonna have to expand that pronoun there for their customers. I don't know. There is gonna be pro widget systems. So I'm just gonna expand that. Let's say whether pro widget systems are primarily London based. So I kind of have an idea for that. That's well, that's weird. What happened here? What's going on? There we go. Is it just checklists like that? No, it's not. Why? No. Okay, so I think it's because you need to have a space. No? Oh, that's so weird. Why? Is it not possible? This is something that I was not expecting to encounter. Um, yeah, but it's not working. iPie widgets, is that what it is? Yeah, no, that's not what we want. Because those iPie widgets is gonna that's gonna be usable. You can check something off and then have some options to click and see, you could tether that to running some code, to parameters of something in your visualization or something like that, or the running of your code actually. Do I have Markdown all in one? uh I'm pretty sure I do. Isn't that installed? It is installed. Why does it not work? I don't know why I have to have checklists, but it just seems weird. It just seems weird that it wouldn't render it. It's like, what are we doing? Like, that's a pretty core. It's pretty like core to every single markdown specification. So why wouldn't that work? That's so bizarre. Is it double space? No. So weird. I don't understand what's happening with it. I don't know. That's weird. All right, whatever. Me futzing over, that's not going to solve anything. I'm just really annoyed. I'm just really annoyed that it doesn't. Gosh. And then I wanted to actually get the data. So jumping ahead here, so we have these two things here. Addresses and cities. We need to wrap these in quotes because of the special characters. The dashes. All right, so that's the problem. So they're a UK-based business-to-business retailer. So if this were a sanitized tutorial, our data would likely have a column called city, and our task would be more about the technical steps required to group the data by city and summarize it using an appropriate metric. But perhaps we would take the total spending from all London-based customers and compare it against the same figure from other major cities in the United Kingdom, or all data where the city column is not London. So let me take a moment to think about this. Which UK cities are currently underserved? So we need to find out, where in our data we have. Okay. That there. So which data do I need? So I need to know where they're pro widget systems and they're business to business. Which ones are underserved? I'm gonna say what does underserved mean? I think that we're going to say that underserved is probably going to mean that we have the fewest number of customers, or even like not as many customers in those areas, that we're not serving those areas, right? So we need to know where our customers are and find out if there's any. Yeah, this is kind of weird though, because we need to figure out like, so which cities? So we need to find out which cities are going to have like the fewest number of customers. But the problem with that, it could also mean that there are no, like, underserved, meaning that we actually do serve them, but they don't, that they're not, that there's just very few customers there, rather than underserved, meaning that we have no customers there, right? Is that a possibility? That's what I would like to know. So I think I would like start asking a question on like, what does under, so I'm gonna do italics. What does underserved mean? We'll say, is it amount of customers? So like, for instance, like, i.e., do we include areas or cities which currently have no customers? That's a question that comes to mind. Which UK cities are currently underserved? And then we have to understand, like, what does currently mean? Unpacking that. Currently mean. So is it... we'll say, what is the latest that we are including to, you know, understand if a customer is current? And then what does underserved mean? What does currently mean? UK cities is pretty clear, I think. So I guess like what are considering a city, right? What are we considering a city? Right? That's another question, because grouping the London metro area, right? London metro area. And so that's kind of like also like London based. How do you know whether or not they're London based? So like this is gonna be, for instance, are we grouping into I'm assuming they're suburbs, like into city of London, right? And then there could be others, right? Like how far of a radius are we considering being the city? And that's just with question 1, basically. But also, like, to do this second question, whether the customers of Pro Widget systems are primarily London-based, that also we need to understand what we're talking about when we talk about a city. And what do we mean by primarily? How do we know when a customer is primarily London-based? And so, like, what data would we need for that to know that, right? So we need to make some assumptions, I guess, when we do this. So whether the customers of Pro Widget systems are primarily London-based. And so a customer, I think, like, the easiest one to answer right off the bat is, what is a customer? And I think it's my assumption is that it's a business that buys from, I'm going to say PWS, Pro Widget Systems. So let's go ahead and call this PWS. What is a customer? Customer is a business that buys from PWS, Pro Widget Systems. I think that's what that's going to mean. And so have I tried to, so those are questions, I think, and I'm still in the process of understanding the problem, right? And so let's see. If this were a sanitized tutorial, the data would likely have a column called city, and the task would be more about the technical steps required to group the data by city and summarize it using an appropriate metric. And perhaps you would take the total spending from all London-based customers and compare it against the same figure from other major cities in the United Kingdom, or all data where the city column is not London. And perhaps you would choose to show the distribution instead to get a more detailed picture of the difference, right? So we would try to find, we try to find the distribution by city, right? The counts by city. But also, like, we're probably, when we're saying whether the customers, we're looking at the number of customers, not how much they spend, right? So either way, the choice is more about the specific technical steps required to get an answer in the sanitized tutorial, right? If we're answering this as an analyst in a real business, the available data is not organized cleanly enough to have a city column. We only have a single customer address column. So this is okay. So in our project, we only have customer address column, which may or may not contain the city somewhere within it. And the address data for this project comes from Companies House, an executive agency sponsored by the UK government's Department for Business and Trade. And the original public data, which has been modified for this exercise, is available at that link there. And I'm actually just going to curl it into my data folder there. So actually, what I want to do is import data. Import Datadir. I don't know why the vim didn't work there. All right, that works. Okay. And so we'll do addresses df is going to be pd.readcsv. So we'll do our imports here. So we'll do that from there, and then we'll do pandas. Take a long time to load pandas. Oh, that's not going to work. Oh, wait, it did. Oh, we could read it directly from there. Oh, that's fun. Let me see something. Ah, total spend. Now we need to do some massaging there, right, of that, because it's all over. Huh. Yeah, that's a weird one, isn't it? Hmm. So they have only 100,000 companies. Interesting. The company ID is there. Okay. Huh. We're gonna have some messy data to deal with here. Addresses DF. Then the city's DF. Birmingham, and there's a star on there, so we gotta work on that. Brighton and Hove, this could be dirty as well. There could be Brighton and with an A, with the word and it could be the ampersand there, so could be on the lookout for that. Let's see. So we have our datadir. So we just loaded that right in. But what I would like to do is to save the data. That's what I was trying to do originally. But what I'm going to do is to and what we're going to do is to go. Oh, geez. Okay. I thought this was going to be inside of there. Okay, we might have to run this again because of the thing there. This might not work because it's going to be from a different thing. Yeah. Relative with no import. So, right. Yeah, do that. I think what I actually wanted to do was not curl it in. Run the py file for getting data. Although, I guess that could work. Could do relative import from there. Just do ... data. And then do addresses.csv. And then put that there. Looks like it worked. I did want just that, but I mean, yeah, I guess that works. The other thing I wanted to do so I guess what we do init.py. Just do that. Virtual name data. You do relative import. For the billionth time. Init.py. Subpackage. And so I think you need one for here as well, right? Valid syntax. There's really something I need to know. The import system. So Which two? What are you talking about? Alright, I don't understand this. So 1, 2, 3, and so in the parent we have that. So we're just gonna be learning as we go here. It's already 3:40. I gotta not spend too much time on this. So, where's a Python init file? It's just blank, isn't it? What do we put in it? It can be blank though. If you know what I'm trying to do, please let me know how to do it. I swear to God, if he loses import lib, I'm gonna like, why? I don't know if it's actually working. Maybe it's like okay, well, I'm learning something here. Okay. So I guess what I'm going to do is take that data.py. I'm just going to move that into the there. I'm going to delete these. And we're going to take that data.py and we're just going to take this path variable and we're going to delete that file. Delete that file. Yeah, we're going to move it to recycling bin. Then what I'm going to do is to parent. And then the data dir, and then if I do resolve, there we go. There we go. I thought I had. So can they have multiple locations is a question I wanted to ask before. Okay, so we're going to do this. We're going to do data dir. And we're going to do there we go. All right, so we have our addresses and cities in there loaded in. That's all part of obtaining the data, right? So let's So this is actually part 5, I think, right? Or 4. 4 is the data. And then, so it's going to be the problem. 4 is going to be the data. We're going to actually additional resources. So we're starting at the end. So actually, this is the problem. 2 is the problem, right? And then so understand. And then what did he say about with the results-driven approach? So the output of the first step should be a clear, defined terminology agreed on by those there, a clear question. And then once we get to the start at the end, it's a clear picture of what the acceptable solution will look like as the deliverables. So we'll say deliverables is what I'll call that part. The problem, the deliverables, let's say additional resources needed, the data, and then after we get the data, what we're going to do, let's take a break in a minute. Then we do the work, right? The work. And we'll call this 6, 5. 5 is the work. I was a jerk. And then so the minimum viable answer is going to be presented as such in this notebook, and that's what we're going to do. And then so, and then what I'm going to do is say the iteration considerations. The iteration considerations on the next one. So the problem, the deliverables, the additional resources needed, the data, the work, the minimum viable answer, the iteration consideration. So try to do this all into one notebook, although some other stuff may, like I may want to export some of these problems, some of these yeah, I may want to export some of these into Python files that I can run, and then yeah, just to abstract it away, like run the data cleaning thing in a separate file, just to be clear with the delivery here. So yeah, I'm gonna be back in a few minutes. So all right, popping back in. Let's get going. Finishing up this project. I'm just gonna peek ahead to see how much how many pages I need to get through. I need to get up to 33. Need to get up to page 33. We're on page 12. Page 13. Well, page 12. Gonna be a big one here. Yeah. I'm not sure. Still not working here. There we go. Yeah, I'm not sure how far I'm going to be able to get with this, but at the maximum, I think what I was going to do was get my minimum viable answer. And then clean up the notebook, and then present it like tomorrow. Well, it's fresh in the mind, right? So, yeah. Okay. So in this project, the available data is not organized cleanly enough to have a city column. We only have the single customer address column, and there may be a city in there, right? London, Bristol, Sunningdale Gate. Okay. So we're going to need to clean this up a lot. Yeah. This is going to be messy. So the address data for this project comes from Company's House. Sponsored by the UK government. Right, and so we have that. So we need to identify what city an address relates to. And we'll follow the results-driven process laid out in Chapter 1 to do this and get an answer for our stakeholders. So the real business use case is finding new leads with address data. So as a data scientist, one data-driven tool built by David Asboth was a map of all of their customers, combined with a list of all companies in the United Kingdom that were in a relevant industry to be potential customers. The sales team used this map to identify prospective customers in the local area whenever they went to visit an existing customer. The project involves combining their own customer data with the government's official public list of companies. And the bulk of the work was sanitizing address data in both lists so they could be compared, which is why that is the topic of this chapter. So I think if we have the cities there, we can clean up that cities thing. $79 non-nulls. And there are 79 total entries. So they're all non-null. And the column's England, so... in England, Bath, England, that there. So somehow he ended up with a list of the United Kingdom things, right? So major cities there. So these were my questions, and he already like gave us the data, so like we already had like most of that there. All right. Let's talk about deliverables here. Well, first let me understand the problem. Total spend needs to be greater than 0. So there are a bunch that have total spend equal to 0, right? Okay. What do we do with that then? So our total spend ranges from 0 to 11,000. I assume this is in like thousands. So that would be like 11 million. Because otherwise, that's really low to have your max client be only giving you $11,000. And that's like lifetime, right? Total. Hmm. Maybe not. 495 mil. Okay. Viable business there. Maybe they're like an office supply thing or something. Excuse me. I'm going to try to work through this, but I really should just move along. My assumption here, because I can't go back and forth with anybody here, is that it's going to be we don't have dates on this, right? We just have addresses. We have addresses and we have total spend. Some are missing. Some are even missing addresses. We got a company ID. All right, so there are 100,000. So every single one is unique. We have companies for which we don't know their addresses. My assumption here then it is unique in the data set. So those are the assumptions that I'm kind of making here. I don't know why I keep doing that. Well, I know why I keep doing it, but I don't like it. Okay. So that's the problem. So now that I have the assumptions, the clear like goals here. A customer is a business that has total spend greater than 0 from PWS. They haven't spent anything with us, then they don't really have, right? They haven't spent anything with us. I don't know if that's a good assumption. But I'm going to see if it works, like see from there, and then see if we need to relax that and just say that like all businesses, all companies in our data set are customers. I mean, that could like trying to find out whether or not they're currently underserved. That could play a difference, right? Yeah. So this is so customers. What is a customer goes into customer into the second question. Trying to find out whether they're primarily London based. So okay. Yeah. So that's going into the second question is what a customer is. I'm going to use that assumption for the second question, but in the first one, we're going to relax that constraint to say underserved means that it's cities in which there's the lower 5% of customer count where we count up the customers in there. So, and then so I'm going to also make another assumption here. Is the aggregate count of companies grouped by city? And we'll flesh that out later in the work. Lower 5% of total spend. Yeah. That I don't think I need to flesh that out. That's pretty clear that I'm going to aggregate the total spend for the city and then see like how we're not bringing in a lot of money from those cities, right? What does underserved mean? Yeah, cities in the lower half, so we'll do that. So what does currently mean? So I'm just assuming that every company in the data set is current, every customer in the data set is current. So yes. Every currently underserved. So I'm going to say every company in the data set is current. So are we grouping the London metro area with suburbs into the City of London? I'm just going to assume that we're not going to do that. That I'm not going to go that deep. We're just going to go simple first, right? What are the considering cities? So the assumption is that the city is going to be well defined as it appears in the address column in that string, right? It appears in there. It appears in the string. The string representing the address in the address column, right? Right. Then how do we know when a customer is primarily London-based? I'm going to assume that the company ID is well-defined. We already know it's unique. I did check that. So that's the answer. Like, can they have multiple locations? I'm going to say no. I'm going to say no, they don't. And then I'm going to... Company ID is well-defined and unique. Unique in the sense that it's not going to point to the same address, right? Although maybe I shouldn't make that assumption. Maybe I can test for that. Oh, what? So that the address doesn't correspond to 2 or more company IDs. That's an assumption I'm going to have to test. But let's just go with that assumption for now. And if there's an error, then we'll find it later. A little sloppy, but like, right? I mean, it's just the way I want to do this. So we want to know which UK thing is which is primarily there. So we're going to look at the deliverables. So the deliverables that we're going to look for here are going to be so a chart of the distribution. We're going to go for those charts, right? I think those are the main things. Those are the main things we wanted to show in order to show whether or not you're currently underserved, right? And then to answer the second question, whether the customers of Pro Widget systems are primarily London-based. Well, primarily, well, what are we saying? Let's go with a visualization for that as well. Versus all others, right? Or let's go versus all others. So I think what I'll do is, like, if London's not the one, if it is, then we'll show it. If not, then we'll do something else there, right? I think those are the deliverables. I think that will answer the question. I'm not sure if I'm getting this correct, but I think this will help us understand. We can do this in numbers. I'm going to try to do this visually as well. The additional resources needed. I'm not sure if we do need any additional resources. What we might consider, there it is. Okay, that's quite handy. Might consider for iteration. For the metro area, based on the metro area. We might consider that for those purposes, but for now I'm not going to. The data... So we have all the data. We have the data there. So I think we just have to work through it. So we have these things here. This is the data. So let me... yeah, I think what I'm going to do is just move this up. There we go. So the work is going to be here. This is how we're going to do the work. And this is going to take a little bit, right? It's going to be a little bit to do, and hopefully I can do this quickly, but I doubt I will be able to. But I will give it a go and see if I can do this. My plan, my plan here, let's say my plan. My plan is going to be to clean cities DF, right? asterisks, check for duplicates. Check for duplicates. Check for duplicates and drop, right, if need be. Although, with that Brighton and Hove, that's what I'm kind of concerned about. Don't want to drop. We may need to merge them into like a list. Right. Create a new column in So I don't think I'm going to check for duplicates right away. Don't drop, though. Save for later. We're going to create a new column for the addresses DF for the city, and we're going to check if what am I doing? Check that all have been matched. We don't want to lose data, right? Because that would kind of like undercut our idea here is that we want to make sure that we are finding the underserved ones, and if there's cities that are not listed on there, maybe we're have a blind spot there, right? We could bifurcate it that way, but I think we're just going to do simplicity first, right? Condition on a match. So we condition on in the address string, right? But the city name is in the address string. That's the goal. Then what we're going to have to do is, so we have that new one. We need to aggregate pivot table maybe. I think pivot table will probably be the best way. Because we could get both of those ideas in there. We could get both of those customers, the number of customers and the or the total number of customer count, and we could get total spend in there as well, because we could get both of them on. Okay, that's my goal. Aggregate by city. And then we create charts and resulting pivot table. That's my plan. Okay. So let's hope that that's what we can do here. I need to clean cities DF. Now, again, let's take a look at N unique. We see that we have 78. There's actually There's actually one repeated in there. So if we go with the unique, oh no, okay, so 79. We could also take a look at this as well, right? Addresses, company, and unique. Oh, you know what? Let's just go with all of it. There we go. Addresses. There are repeat addresses. Oh, shooty magoody. We do need to take care of that, don't we? Okay. But it's a different company? That's messy. And then there are 111 total spend. Well, that's like, okay. We don't have to have that on there. Huh. So 25% spend 3,900 or less. 25%, right? Most of them are within this like small band. There's like, it's definitely, huh. And then there's a big whale. I don't think it's normal. But that's not what we're trying to answer anyway. Bath, Birmingham, Bradford, Hove, Bristol. Okay, what do I want to do this? Cities unique. I want to do. All right, so there are multiples in there. So, we're gonna clean. And what we're gonna do is we're gonna take England as that. And we're gonna replace, right? With a blank. And then I just want to see like what we get from there. So we get Newport in that. I think that's all we want to do. And I think what I'd like to just, I think it's okay if there's a repeated one. I think the 79 and there's 70. There's 70. So there is one repeated. Well, let's take a look at which one that is actually. Do a mask like that. So it's Banger. So Banger's in there twice. 72. So that's the duplicated one. But why is it? I don't think it really matters for this. So what we want to take this one. I think what we're going to do is we're just going to clean it, right? Cities. Clean. We're going to say that. And move this one up. And then what we need is addresses. Yeah. Right. And then so all of these are in there. So London's in there. So the very crude way to do this is probably not right, because you could have cities You could have the case where the city is like what happens if it's on Banger Street, right? And then I go searching for that, and then I see what the match is there. That could be a problem, right? Yeah. These addresses are really dirty. Because we could end up cleaning these things, but we might not have to. Right? We might not have to. It might just be as simple as just doing a case and seeing if it's in there. So cities. So how would I do that, right? How would I match it up? I'm a little stuck here. What I want to do, so I'm in the second part of this, right? Right. We've removed the asterisks. We did check for duplicates. It's Banger. Create a new column for city, and we want to condition it on the city name being in the address string. But then how do I do that? So we want like, yeah, that's pretty costly calculation wise. It's to like go through every single city's. I mean, it's a small amount of data, but in the scheme of things, less than 100 points for 100. Go through everything. Try to see if it's in there. I guess what I could do with the addresses is to do a split. Right. So we could split it on there. Then it's just a matter of finding it in the list. Can I also do it as that? No. So we can split on that. Can't do a list. You can split on that, but you can't do split on multiple. So we want to find out what that is. All right, so you have to use the RE thing, right? So let's go back up here. We might clean that up for later. Cherry could be in there too. Yeah, that doesn't quite work. This is tricky. I'm definitely a little lacking in the technical spot here. But let's see. What do I want to do? So I think it's like join on substring, right? Merge based on a substring and a string, right? So the pattern. Yeah. Yeah, that's difficult. DF search. I feel like we could do this with folders or something a little easier. This example looks messy. Okay, we could lambda apply that. That might work. Let's try that. Let's try the lambda apply method. Let's see if that'll work. What we want to do is take the address column, right? We have the data frame 1. Join equals 1. Why join equals 1? Well, you're doing a full outer join there, basically. I don't know why you had to go through that level. Outer join and then just filter. I guess we could do it that way. I mean, I guess we could do a cross product, right? Cross. That's what we want to do. Oh boy, takes a while, but there we go. Oh wait, we got cities df clean or something. And we can take the head of that. And then we could, like, I guess we could drop them based on that, right? I guess we could do it this way. I mean, we create a mask here. Yeah. It's not work name. We're doing it by address. Doing it by address. Find. native one. I didn't find any of them. Oh, that's a funky way to do that. False, 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 and then true. Okay. They're all false. Shouldn't be, right? um, they're all just false, so I don't think that's working. Find something from their X sub work name. Axis equals 1. Or maybe it's supposed to be on 0. Oh, right, okay. Yeah. Hmm. Oh, wait a minute. Come on, really? um, a little lost here. Not sure what I can do here. I think I might need some help. So let's see, data dictionary. First step in understanding what's in a data set is to read the data dictionary or ask for one if it wasn't provided, and you may ultimately need to write one yourself. One of the ways the real world differs from this book's projects is that well-documented data dictionaries are provided, but don't get used to it. Right, we should write our own for the supply data. So we should write this, right? And so it does look like it's GBP, the total amount this customer has spent to date. A single field to store the customer address. So we make those assumptions, and then if they're wrong, then we correct them, right? We assume the definition there. The address is a single field to store the customer address, and then it's a customer company ID is a unique identifier for each customer company in the data set. But we also have, addresses are overlapping here. So that's a problem. So now that we have our problem statement and have seen the available data, it's time to start our results-driven process to arrive at a solution, right? So finding London is a difficult thing here, right? So, I mean, maybe we want to do this. Still don't work. Yeah. I don't know, man. Okay, so I have some trouble here. So in this section, I will dive into an example solution, focusing on the steps of the results-driven approach as well as details of solving the problem. You may wish to attempt this problem yourself before going further, or use this chapter to get a feel for the structure of the rest of the projects. As for most solutions, the code itself will be written in Python. So I just need to accept that, like, there's some things that I need to work on, and then I'm not going to solve it today. Yeah. Okay, so the code itself will be written in Python, primarily using pandas. Code snippets will be used to explain the example solution, focus discussions on the conceptual solution, less on the code specifics. The solution will have 3 parts: setting up the problem statement and the data, and creating the first iteration of a solution, and reviewing the work and deciding on further steps. So setting ourselves up for success is the first thing to do, is to understand the problem. The first step is to ensure we understand the problem. I think I understood it decently, but in this case, we need to use our customer address data to calculate the total spending by city across the United Kingdom and come up with an answer for how London customers compare with the rest of the country. So I was going to do this in 2 different ways. I was going to do it with customer count, and I was going to do it with total spend. So both of those would have yielded a good answer, I think, and they would be very similarly formulated for arriving at the answers there with constructing a pivot table. So I'm happy with that. If we encountered multiple metrics in the data, such as the number of transactions a customer has made or how long they have been a customer, we would need to clarify the purpose of the question with our stakeholders so that we know which metrics to focus on, right? In this case, the data provided does not contain this ambiguity. It is clear we are focusing on spending patterns across 2 predefined geographic areas. Alternatively, I mean, asked us about which areas are underserved in general, we would also seek to understand whether we should look at data at a city level or a different level of granularity, right? With like the metro area, right? Or like streetwise or something, I guess, like different levels of granularity. Starting at the end, the crucial step in the analysis is to think of where we're going, what form will the minimum viable answer take. And in this example, stakeholders have two questions. Are different cities underserved? This requires us to calculate total customer spending by city and find cities with the lowest customer spending. All right, and I was looking for the lowest 5%. And so how does London compare to the rest of the United Kingdom? This can be answered from the output of the first answer. For a minimum viable answer to this, a minimum MVA to exist, need to add a city column to our data, and it's just difficult. I am having a tough time doing this, which we will extract from this address. So this will allow us to have a breakdown of spending by city, meaning we could take the row for London and compare it against the rest of the table. Right. As a final output, a table or bar chart will suffice for both cases, but it may seem obvious, but knowing the exact format of our output will guide us toward a relevant solution. So yeah, so I am kind of like, I do think I can do it this way. I'm not sure. That works. But it's saying true for London is in there. um, right. Right. Okay, wait, because that's not the mask. Right, we didn't even need the other city thing. We could have done it just on addresses, right? So I could have done that just on addresses. I got a little in the weeds there and trying to answer the big question first, when we could have answered one of these. So I could take addresses DF, and I could just take a non-Boolean array. What? Why not? Oh. NA values. Right, we'd have to convert. That works. That works. Okay. Now what we could do is we could take the sum. I guess that's going to be weird though. Yeah, okay. And then we could take the negation of this, right? Yeah, it is that. Okay. Hmm. Some there, okay. We could do London spend. And that could be integer there. And then we can do it looks like that's false. Looks like London is there, but the problem is there. Yeah, it's not refined enough. We'd need to find the second most, honestly. So it might be enhance the accuracy of our address data. Our first iteration should usually focus on the data we already have. And additional data sources can be considered in future iterations. That's kind of what I was figuring. We didn't really know much about the data going into it in the first iteration. But it's really just like a step to like identify additional resources that you might need. All right, and then so we obtained the data. They just gave it to us, right? The step of acquiring data should not be underestimated. Entire data science initiatives have failed because the data science team never received any usable data to analyze. The obstacles to obtaining data are not technical but organizational in this one aspect of the real world we won't simulate. Yeah, so that was a problem at Lambda School, wasn't it? Oh, we got a data science team. Yeah, what are we supposed to do? You don't have any data for us. Like, it was so ridiculous. So we were like, okay, I guess we gotta fabricate some data. Throughout the projects, you will not need to find any data yourself. It will be provided. It will not always be easy to clean, but you will not spend any time emailing someone in your organization and hoping for their goodwill to send you a data extract. Okay, so creating the first iteration of a solution. So I did something there. Okay, so you can take a look at the shape. I just did the info. It's a little more computationally expensive, but small enough data set. Right. So at pandas. So checking for missing values. I already saw that with the info, right? So you did the is null. There were 968 missing values. Yeah. For the address. Just means we had to fill it with an empty string. So we couldn't make... You shouldn't... Like, there is a point to be made with missing data. There could be a reason why it's missing. So in this case, address not being there, do they not have an address? Like, is the address... What is our assumption about why it's empty? Why it's missing? So it's just under 1% of rows. Since we have no idea of knowing the addresses of those missing customers just from the data provided, we just drop the rows, right? And so we are just doing that. But it is something to keep in mind that when you're doing, when you come back around, to your stakeholder, you go, and we did find these missing values. Is there any information that could salvage some of them, right? Could salvage some of those data points. What percentage of rows is acceptable to drop will depend on the context, but losing 1% due to missing key information is fine. If, say, 10% of our customers had missing addresses, we might want to examine why. However, this is a point where analyses might diverge. The missing address data could either be kept and categorized simply as other, or if we had more customer-related data, we may choose to spend the time looking up a customer's address elsewhere to get a more complete data set. Of course, if we had, customer-related data. That's what I was talking about. So there are many places in analysis where there is no definitive right decision, only different decisions based on different assumptions. Because of this, your analysis will diverge from from David's at various points. Illustrates this branching of possible paths in a diagram. He uses heavily to reiterate his point here. You investigate the missing data, you get an alternative decision, or you drop the missing addresses, or you get an alternative decision. Alternative options at this step include categorizing missing addresses as other. That's one alternative decision. And then the other one is finding customer address information elsewhere, which is not possible here. Right. So I think with all of this, I think the one thing that's popping up into my mind here is that I should be writing this stuff down. Basically, when this happens, when I end up coming up with a thought, I need to record that thought because I don't know where that hid. Interesting. Because I need to be documenting it in this way, in this fashion, and that's tricky for me for some reason. I need to add stuff there. Yeah. What was the sum again? I just need to come back up to here. Just want to make sure that this is correct. I think that's true. I don't know. I don't think that's right. Oh, that's false. How did we end up with more? Oh, it's true. So the missing addresses weren't even a problem because of they didn't. Oh, never mind. I didn't drop anything. It's like it's late in the day, folks. I'm losing it. Okay, so then the other thing, the key, the analytical step, and then the decision taken is okay. So yeah, that's just a diagram. The analytical step is to investigate missing data. The decision that you take is a result of investigating the missing data. That's just where he's denoting that kind of thing there. So there's two shapes, steps and decisions. Steps represent sequential tasks to be undertaken in the analysis, and these come from the original action plan. May also be informed by what you do with the data, and so decisions represent places where the analysis might diverge depending on the assumptions and choices made. Your analysis will not necessarily contain the same steps or the same decisions as mine. While we are exploring our columns, we should also check if our total spend column contains any strange values, such as negatives. The output of the following code snippets there, right? So yeah, I did do that. I looked at the describe of the total spend, and because I was very curious to see like what the distribution of that looks like, right? I kind of wanted to, I was going a little bit too fancy with the chart idea, right? I really just need to get the numbers. Just get the numbers. That's all I need. Just get the numbers. That's the lesson to take from this in the first iteration. Don't get fancy with charts. No fancy charts. Okay, so as the, I don't know why this, there we go. Can I go further? 170? Does that still fit? Hey, it still fits. I think that looks great. Okay. Right, so the values range from 0 to just under 12,000 with no negative values. Now that we've seen our data, we need to decide an approach to extract the information about cities, and let's think back to our stakeholder questions. Are different cities underserved, and how does London compare to the rest of the United Kingdom? Second question is a subset of the first. So once you have a data set of customer spending by city, it's easy to compare London against other cities. To solve one question means solving the other. So if we start by focusing on identifying addresses in London first, we can find the nuances and edge cases on how addresses are represented. So yeah, I did take a look at those ones. You can already notice some patterns as well as some potential pitfalls from our limited sample. It appears that addresses end with a postcode, but sometimes London addresses contain a line for England, sometimes they don't. This means we cannot rely on looking at a specific row of an address to give us the city, which is useful information. What about looking for the string London to identify customers in London? Would that be sufficient? Probably not, because you'd end up with including people who live on London Road. Pointed that out earlier with like just the Bristol example, right? So in other towns for a start. So examining the data, we can see that address lines are separated by a column and a new line character. Okay. In general, but that's not, is that like true for everything? So separated by a comma and a new line character. Note the extra column, comma in the search string. Our rule could simply be the following. So what we're going to do, we're going to try to come back to this other iteration. I'm going to save mine. I didn't actually answer the question. I didn't actually get this done, but that's okay. It's the first day back from a while. So what I'm going to do, I'm going to take this, I'm going to duplicate it. I'm going to copy it. I'm going to paste. So that's a copy. So what I'm going to do is I'm going to rename this as iteration 2. So this will be iteration 2. Basically, what we're going to do, so we get the data, right? And did this run? Or, yeah, we still need to select the data there. So we already have our data there. The deliverables, can we like run this? Yeah. Okay. Deliverables, that, and then the data. So we get our data. And so I'm going to use his same idea here. I'm going to call them customers, and then I'm going to call them cities. I guess, like, do we call them cities or something? Let's see what cities. He calls them cities. Let's go with that. Just call them cities. Now we'll get to the work. Now from the work, what we'll do is we'll do customers. Address clean. We can just add a little column onto our thing here. And we're gonna uppercase it just to standardize it, I guess. And then what we can do here is okay, so customers address clean. If the string contains London, then we can look at the difference, right? We can just copy that, and then I can look at the difference here. Where did he do the dropping? Drop in a subset. Yeah, okay. So there are slightly different numbers of these things. Right. I get those numbers respectively, which means there's nearly 1,000 rows are no longer selected when we add the columns. Those are the addresses that contain the word London, but we assume are not in fact in the city of London, addresses on London Road. So we've already seen from our sample addresses that we cannot rely on the position of a row to decide where the city component is. However, there may only be a finite number of address structures. Let's look at how many addresses consist of how many rows, and the output of this code is shown in figure 2.6. Okay. So it's almost 6 o'clock here. I don't want to wrap this up, but we are like several pages behind. Do want to just like kind of work through David's example here and get through this. I think I learned a lot from this, and there are some takeaways here, and namely, like the takeaways that I'm getting from this is that like it's okay to be dirty, right? It's okay to try to like to use everything at our command to do this. Like I don't have to do it, quote unquote, the right way. I don't have to like go and like maybe it would be nice to go through okay. It would be nice to do the pivot table example and get that nice and clean, but you know, that is that would be in a much further iteration. Okay. Right. You should observe that some addresses consist of only 1 or 2 lines, and some have as many as 6. And so, in theory, if every 3-line, 4-line, 5-line, and so forth address is consistent, we could come up with a rule to extract the city slightly differently from each. We should also examine some of these shorter addresses to see what they look like. So the output of this code is shown right here, right? And so we'll do that here as well. Just make sure that we have the right numbers here, yeah. So we split an address into a list of substrings and then separate the rows, right? And then count the length of each list, and we see that like, yeah, okay, so that's interesting. That's an interesting analysis to do, a little meta-analysis to do on the data set, on the addresses there. So now you count how many addresses are made of how many rows. Okay. I don't need to use print because I'm using the notebook here. And then we will take the, oops. We'll filter by that, right? Where the address lines are 2, and we could do couple there. What we're trying to do, I think. Random state is just for this book here. Yeah, it's just for reproducibility of trying to find get the same results as the book here. Okay, so we do. Yeah, well, that's clear because. Oh, okay, right. Those are the exactly 2 lines for that 4 Far Angus, 12 Hope Street, Edinburgh. All right. Well, this is in UK, so okay. Some rows are simply city, Falkirk. There are entirely missing addresses, referring us to a parent registry, and we also have PO box addresses. And it's unlikely we can come up with a rule to extract cities purely based on their position in the lines of an address without writing a lot of bespoke code. And that's the thing, though, because like you really want your analysis to be repeatable. You want it to be also robust to changes in the incoming data. You want to be able to run those same files, the same sequence of code, and get a reliable result, right? And if we're doing bespoke code, then we have to bespoke it for every single little change that comes up, right? Generally, that's what ends up happening. Is that like you have some slight change, then you have to consider another edge case. Let's remind ourselves of our goal. So our immediate task is to create a city column, and we now have to decide how to proceed. One option is to take our London finding example and extend it by explicitly looking for city names in the address column. This would require a comprehensive list of cities in the United Kingdom, which is not an impossible task. Such lists do exist. For example, there's one there provided by the UK government. In this case, we would still need to decide what to do with addresses that fall outside of these cities. Do we simply label them other? For a first iteration, this may suffice, as the question was specifically asking about cities, not towns or villages. And so I jumped ahead here because I went to the code, to the GitHub code. Oopsie. Well, I mean, it is what it is. I'll try to follow the process better as we go along. But that's that. All right, another option: use postcode component of each address. Look it up against the National Postcode Database, which we could have to obtain and ensure we are allowed to use, right? I think that might be a GDPR issue, I guess. But then I don't think the UK is the UK still bound by GDPR after Brexit? I'm not sure. I know it's a European Union thing. This might be a more accurate method. Well, would require additional work, such as identifying the postcode component of each address in the first place. You'd have to use regex or regex, and I don't know if postcodes are standard in standard lengths in the UK. In the US, there's 5 plus a dash and then 4. So there's 2 different formats. So, but you'd probably just be interested in the 5 numbers. So you could extract the 5 numbers in that way. Then you need to make sure that like the 5 sequential numbers are not a street address in the address, right? So we are on the side of less effort for our first iteration, so we will attempt to use the list of cities in the UK provided by the UK government. So the web page is a bulleted list of cities for each country of the United Kingdom. An extract which is shown in figure 2.9, I think it's down below here. And so there are multiple ways to extract these into a code-friendly form. The simplest one is to copy and paste the bullet points from the website directly into Excel, so each city is on a separate line, and then import and clean the data in our code. The quickest option isn't always to write code, however. For full reproducibility, you may want to automate that step. Obtaining this data manually will suit us here since we don't expect the list of UK cities to change very often. This raw data is provided. And so, okay, so you just take it from here. And the asterisk indicates the city has been awarded a Lord Mayoralty or Lord Provostship, whatever that may mean. So we have all of the cities there, Brighton and Hove. And yeah, so we did do this. So names equals city. And so we can, let me go back up to where we defined our data. And I'll just run it all again. So we were looking for a header with none, and then we're looking for names. That was my plan. My plan didn't work out so well. Yeah. That sucks. So there's clearly some aspects of this data to clean before using it as a definitive list of cities. And first, the country headings were included as rows in the data, so the values England, Scotland, Wales, and North. Interesting. So I thought there was only 79. And we gotta remove. We'll see. So it removed 4 of them. Yeah, so 1, 2, 3, 4 did remove them. So let's go. Okay, city. You have to specify regex is equal to false because I didn't think that you needed to. I don't think you needed to do that. I don't think you do. Oops. Whoops. New shoes. Okay. Just kind of delete all this other stuff that I did. So that was one approach that we could have taken. Sample of our clean data set there. There we go. We have capitalizations there. Okay, so now that we have a definitive list of cities, we can use it to create the city column, and figure 2.12 shows the work we've done so far in the alternatives and most recent step, right? So investigated missing data, we dropped missing addresses, and then we tried to extract city column from address. That is our way here, and so the alternative options at this step is to look up an external list of both cities and towns, extract postcodes and finding the corresponding cities, geocode each address using an external API with Google Maps or something similar. So extracting postcodes and finding the corresponding cities. Okay. I do thank everyone for checking my stream and my videos out today. I think I'm gonna wrap up pretty soon, but this is a great start for me to get back into this. It's just like really good to start, get the brain churning, and go through this. I'm gonna try to go through as much as I can here. Basically just kind of taking David's examples and just verifying that they work on my machine, and just try to get the brain going again. We can use our city list to tag an address with a particular city if that city name and an additional comma are found somewhere in that. Yeah, the brain's just kind of fried now. So I think I'm going to stop. So we're going to stop at creating a city column, and so I'm going to mark this off. As creating a city column. And then we'll come back to this tomorrow. We still got 10 more pages of this. So we will finish that up tomorrow. And I'll make sure I get that done out of the way immediately tomorrow. So I'm just going to keep everything up and go through that. Yeah, I don't want to take a break and then come back to this, so I'm just gonna stop here. So let's go back to our things here. I don't think I need to add any more resources. Some takeaways from today. Yeah, I think what I want to do is to add something at the bottom here. Some takeaways for today. It's okay. That over here. Let's come back over to this center here. Slide it right over there a little bit. There we go. Just try to answer the question. Right. That's always a problem. I try to go too deep, too fast, right? So first iteration, just try to get the answer, right? Just get an answer. Just try to approximate the answer to the question, right? So that's okay. In the first iteration, is just approximate and then try to go through that. And then we do want to be thorough, though, right? We want to make sure that we do get an answer that makes sense. Another takeaway is very rusty with pandas. So Reuben Lerner, I'm gonna have to hit up his channel and his examples to learn some deeper techniques, and probably go and look up some other stuff too. So that's, I think, the two main takeaways. What's the third one? I think I'd say, like, yeah, check back in 4 weeks. Check back in 4 weeks. That's the thing. I'm not quite ready yet. Check back in 4 weeks. I thought I'd be able to, like, work through that example pretty quickly, but it's definitely, there's a lot of rust there. Especially with, like, string methods. And yeah, I think, like, this is a challenge, I guess, like, for a lot of... So it's a challenge, right? Because it's not well structured. This idea with the address lines, that's a good, that's an interesting approach, right? To examine the address a little bit deeper. I didn't want to go that deep, like, because I'm a little bit, like, I guess it's an art to approaching this. You might not go that deep with that analysis of diving into the address data. I just was trying to get something easy. Even if it wasn't the correct answer, we just wanted to get something down. So we'll come back tomorrow. We'll do the creating a city column. And yeah, it's, day by day. Day by day, we just got to take it. And tomorrow we will take a look. What's on the docket for tomorrow? Let me take a look. Tomorrow. Yeah, okay. What's going on there? We're going to finish up this this example here, this project, then we're going to dive into that data modeling one. And we also have so it's going to be a new data set and stuff as well. So we're going to model customer data. I don't know if is this a project? Yeah, it is a project. Okay. And then as far as practical statistics for data scientists, tomorrow we're going to look at the binomial distribution and the chi-square distribution. I'm not expecting those to be very long. So I think, yeah. So I do have to duck out after lunch. So it's going to be a longer lunch period. I'm probably going to be taking like 2 hours in the middle of the day tomorrow. So expect that to be long. Oh, I forgot to be adding the stream markers and stuff today. But yeah, okay, so how long have we been going here? We are been going 9 hours here. So yeah, I think it's time to pack it up here for today. yeah, if you're looking for a job in data right now and you're watching this, drop a message. Yeah. Let me know how your journey is going. Be sure to add me on let me see. Bring this up. Nobody came into the chat today. Come on. Yeah, be sure to add me. My hair is a mess. So I look like a Goblovian from It's Always Sunny. That's all right. Yeah, be sure to add me on LinkedIn. Check the I think I have it on the channel page. It's also might be in the description, but it's also in the chat. So check the chat. Yeah. Larshi. That's gonna do it for today, I think. So until tomorrow, folks. Let's hope we have a country. Let's go check it out and see that we still have a country. I follow a account on Blue Sky called Missing the Point. It's pretty funny. They just like post satire stuff, but it's like Poe's Law type of satire where it's like, oh my god, this could really be true. And they say, one way or another, we're one day closer to Donald Trump leaving office. One way or another. It's a great mantra for getting through these tough times. So, have a great day. Enjoy your evenings. And if you're watching this on repeat, yeah, it's fine. All right. Ta-ta.